Hey everyone, a couple community announcements here. First off, I am now in Chicago and I've started doing meetups again. I used to do those in Cleveland. The one here is called 3H, or Hardware Happy Hour. The first one is coming up next Tuesday, December 6th at 6:30 p.m. at the Haymarket. If you're in Chicago or you know people who are, we'd love for you to spread the word. There will be a link in the description. Secondly, we are having a contest based on a book that was donated by David Bengston. It is a signed copy of The Art of Electronics, which is very awesome. The way you can enter is to share the episode you're about to listen to. So, if it's on Twitter, share a link to this episode, tag the Amp Hour, or send an email to contest@theamphour.com. You can also share via Facebook if you want to just screenshot that and send it to contest@theamphour.com. And finally, my favorite one, if you want to tell a coworker about this awesome episode you're about to listen to, send an email to contest@theamphour.com. Include us somehow. You can BCC your coworkers. If you don't want us to see their email address, you can do whatever you want. You need to prove somehow that you did share it, either Facebook, Twitter, or email. The more creative, the better. So, enjoy the upcoming episode. It was one of my favorites in a long time, and we've done a lot of episodes. Here we go. This is the Amp Hour Podcast. Recorded November 30th, 2016. Episode 325. An interview with David Kronstein.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm David Kronstein from the YouTube channel Tesla500 and Cron Technologies, Inc.
Hey, David, thanks for joining us.
Hey, thanks for having me.
And it is David, not Dave.
Right, we went over that earlier.
We'll avoid confusion, yes.
Right.
Make sure we don't confuse each other.
Right. And people probably know, have been seeing a lot of stuff, including from our own Dave, reviewing your upcoming, your, I guess, running Kickstarter
Currently
project.
running Kickstarter, yeah.
Yeah. Well, that's great. Good timing. Good timing to be talking to you now. So we're recording on Wednesday the 30th. This will go out Thursday the 1st of December. When is that running till?
That is running till end of the day on December 22nd.
Okay. So
And for those who don't know
Christmas
what it is, tell us all about your Kickstarter.
It is a handheld high-speed camera capable of recording 1280 by 1024 video at up to 1,000 frames per second, and lower resolutions up to 21,600 frames per second.
Is that all? Oh, okay.
Yep, that's all.
And you're basically a one-man band doing this too, right?
Pretty much, yeah.
Pretty much.
Help from a few friends, but it's pretty much been all me. Yeah, it's been an incredible learning experience.
And you've been doing this for how many years, like working on high-speed cameras, thinking that you want to make your own?
1.4. So at least 0.4.
Yep. Yeah, I've been working on this since 2006, I would say, is when I sort of got into it. There's
a decade.
About a decade. There's a whole big story of how I got into it, if you want to hear.
Oh, yeah.
Of course.
Definitely. That's why you're here, man.
Yep. Let's see. I was always interested in high speed. I guess it started out seeing all the cool things Mythbusters were doing. I was doing sort of things with compressed air guns and things like that way back when. I wanted to see this stuff in high speed like they were doing on the show, but cameras were just completely out of my price range.
What cameras were they using back then, Mythbusters, right at the start?
I think they were using some old Photron brand cameras out of Japan. They had like this camera head and these massive, two huge, like 100-pin cables that went over to this big processor unit.
Right.
That buffered all the data and stored it to RAM and such.
And they were low res, right? They were.
I think they did. They did something like 1280 by 1024.
Okay,
they weren't too bad. They did HD well before they were even broadcasting HD, but they were only like 500 frames per second, and the quality wasn't that good.
Yep.
Was there ever film versions of a high-speed camera? I'm not a film person at all. So.
Yes, there were.
Yes, they had. There's a couple of common ones I've seen. There's one. They're both made by. Who would make? I forget the manufacturer, but they. There's one like intermittent motion, like how a film camera normally grabs the film, moves it, exposes it, then grabs it and moves it repeatedly. Mm-hmm. They did that up to 500 frames per second. And that was incredible. Like the intermittent motion spins at 30,000 RPM, and I can't imagine how they do this without it just tearing the
tearing it apart.
film apart. But somehow they managed this. And they also made another one this was 16 millimeter. They make another 16 millimeter one that it moves the film continuously across a plane, and this rotating prism scans the focused image onto it.
Oh, wow.
And that can run up to, I think, 11,000 frames per second. So you could do this with film back in the day.
Yep.
Huh.
But you're eating I think it's about $200 worth of film for a 10-second shot.
Yep. But that doesn't matter if you're shooting shooting like an explosion, back in the 60s when they were doing the nuclear weapons, the 50s, they were doing the nuclear weapons, they were filming those with high-speed video and, stuff like that. So,
But they had virtually limitless budgets. Yeah,
right.
Yeah, exactly. Film, we'll just run it for an hour, no worries.
It's like a Gatling gun of film and camera, right? I mean, that's crazy.
Yeah.
Wow.
So so I was looking around on eBay for high-speed cameras all the time. I always wanted to get one. And I think it was an Olympus iSpeed 2 came up, which
the iSpeed, yep.
Yeah, it was 800 by 600, 1,000 frames a second. I said it would be perfect. I want to do all these YouTube shots and things. Started at $150, and of course it got bid up, and it eventually sold for $3,800. And this was just the camera. There were no accessories. I'm pretty sure this thing was stolen.
Right.
But it would have been so cool to get that. And I was so ticked off at not getting that, and I said, screw this, I'm going to build my own. And then
I bid on one of those once. I bid on an Olympus iView, and it was like $1,500 buy it now or something. And I went, I'm going to buy this. This was a couple of years back. But the person had no feedback, right? So I went, I know this is like a scam, but I'm going to do it anyway because I know the PayPal buyer protection, I'm going to be protected, right? Who knows? I might get lucky, right, and actually get it. So, and then I got an email, and then they started, I'm having trouble setting up my PayPal account. Can you PayPal me directly at this other one? And then I knew, here comes the scam.
Oh, and I have a story sort of like that where it actually turned out well.
Oh.
There were these two really 3.5 gigahertz Agilent differential probes on eBay. It was they went for, I think ended up going for $400. He had problems setting up his PayPal, but I was talking to him and he had two more of them, and those are current products that sold for about $3,500 each.
Yeah, they're not cheap.
So I said, how much for all four of them? And he said, I'll give you all four for $900. I'm like, this is a big risk. This is a bit sketchy, but I'm going to take it. This is too good a deal, and it turned out to be real.
Excellent.
I've been using those for all the debug on the camera and all sorts of other projects.
That's right, kids. So go ahead and send your money to the wind, and sometimes you'll get some nice hardware back.
Because we'll get into that. So you used them for all the high-speed serial debug?
Yes.
Yep.
Yeah,
so
it's
we'll get
difficult
into
to
the
do
hardware
that without proper
details.
stuff.
Yep, definitely. So probably most people know you from your Tesla500 channel. How long have you been doing that now? How many subscribers?
Been doing that.
All that sort of jazz.
I think just past. Actually, let's check. Yeah, just past 25,000 subs.
Cool.
Nice.
It's been going up really fast lately because of all the attention from the Kickstarter. I think just a month ago I was at like 18,000.
Nice. And you were going to set up did you end up setting up the second high-speed lawnmower destruction channel? Or did that...
Yeah, if you go check out Will It Mow, I basically set up an upside-down lawnmower and drop things onto it with the... In this case, I had, before I'd sent out all the units for promotion, I set up 4 of them at different angles. So I shot about 10 shots of that, and I'm going to be editing them and uploading them.
Why a lawnmower? Is it just because it's not a blender? Is that kind of the idea?
Yeah.
Different. The whole thing came about when I got a Phantom V4, which is an old high-speed camera from the early 2000s, did a teardown, was able to get it working, and I thought I need something to demo this. So I set it up in the garage with this old lawnmower and dropped a few things onto it, and that video took off massively. So I thought, I'll separate this out into another channel, just because the type of people who would often subscribe to that are not the type of people who would appreciate teardowns, and I want to keep Tesla500 the way it is.
Gotcha. That's good thinking.
And because it's the momentum, the physical weight in the blades, the momentum, those things will not stop.
Yeah.
You know, it's like the destruction. It's
Teenage Chris would like to disagree with you. I have broken a couple lawnmowers in my day.
right.
I'm surprised I have not broken this lawnmower yet.
Yeah.
It's
That's great.
incredible. Hats off to, I think it's Black & Decker.
Try a boulder.
Wow.
That was
Yeah.
Right.
that'll do it. Curbs also. Curbs, boulders,
it's funny,
really anything concrete.
The motor is fine. It's this mower was thrown out on the side of the road because the rectifier burnt up.
Oh,
Really. Well, your their loss is your gain, right?
Yep.
I'm surprised you've only got 2,500 subscribers for a channel where you destroy stuff. What's
I
going
just
on there?
haven't
That's
gotten
just
right exposure yet.
very un-YouTube like. Yes.
Yeah.
Usually destruction is guaranteed.
Yeah, like with
and
all the
they're really
hydraulic
good
press
videos.
channels.
Yeah. Oh yeah, the
So Tesla 500 though is mostly teardown. So if people are interested, Tesla 500 is mostly teardowns.
Teardowns, projects.
Yeah, it looks like some machining stuff.
Machining stuff. Sort of a general like tech channel.
Yeah, that's great.
Cool.
That's our kind of stuff. I think everyone should definitely subscribe.
Yes.
For
One of my faves.
Although they probably already are.
Well,
Probably, yeah.
Yeah,
Most of our audience are.
we've only got
probably-
10,000
have
listeners,
already
so
stumbled across you.
25,000. Yeah, that number works
Yeah.
out pretty much. So,
Yeah. Anyway, you never
David,
know.
what is your background?
I did electronics engineering in school. Yeah, sort of started. I was always into electronics. My dad showed me projects like we were building counters and things using old 7400 series chips back when I was probably 10.
Sweet.
That sort of got me into it. Yeah, I went building all sorts of projects, went to school for it, and then just sort of. I was initially working in battery chargers, and then this high-speed camera stuff got me a few other jobs in sort of digital design.
Oh, so your online high-speed stuff got you jobs?
Yes, like
People
Free-
actually
when-
saw your channel and
they saw my channel. I
Yeah.
think one person on the Amp Hour actually
there you go.
contacted me through the Amp Hour. Yeah,
Networking. Yay.
Hey.
works really well.
Hey. That's great, man.
And they said, hey, we like your videos. Come and design
Yeah,
some
come for an
stuff for us.
interview.
Is that
I
right?
dropped, hey, here's what I'm working on. Here's my prototype, and they absolutely love it. Yeah, going in to an interview with things to show is the best
yeah.
way to get a job by far.
Even better than that is to already have your name established via a blog or a
Right.
YouTube channel or something like that.
Yes.
So they
Yeah.
can check you out. They know you before you even walk in the door.
Yeah.
Oh, definitely.
Yeah,
Yeah.
nothing's better than I've actually asked questions before, like not questions of the person, but like interviews goes well, resume looks good, and you're like, I just can't tell. You can't argue with a YouTube channel. I'm sorry.
No,
Like,
no, exactly.
You actually see what they're doing. It's
Yeah.
not. It's
Yep.
really hard to fake that. It's kind of obvious.
Right.
Yep.
Same with hardware, like you said. I mean, that's true. You bring that into the meeting. There's really, I mean, I guess you could have someone else's hardware, but
Yeah, but if
that's
you
pretty
know
obvious.
about it and you can answer questions.
Yeah, exactly. Well, that's good.
So who was that, by the way? Is
That
that a
was-
secret or is it a,
No, it
is
was.
it on your LinkedIn?
Who was that? I don't remember his. The guy who did a lot of radio stuff. He's been on a few times.
Greg Charvat?
Greg, Greg Chavant.
Ah, Greg Chavot.
I
Okay.
haven't talked to Greg in a little bit. We might have to have him back on.
Yeah.
Maybe we
There
can
you
get
go.
him back
How he's
soon.
doing now.
Yeah. Oh, he's doing that crazy medical thingy, the medical startup thingy.
Oh yeah, on his LinkedIn, I don't see it there. He's doing other stuff now. I'm curious.
Yeah, he got pulled off to other things, so
yeah.
we'll try and catch up with him soon, I'm sure.
Very busy guy.
Yeah.
Cool.
But he's in Connecticut, and you are up in Vancouver, right? So
Yes.
you were just doing remote stuff for that, or what?
I wasn't. No, I ended up not accepting it. I wasn't really ready at the time to move across the country.
Right.
I gotcha. Okay, cool. So, I was gonna ask, what's the scene like in Vancouver? I've sadly never been. I've heard the city's beautiful, but like, what's
It's
the
very
electronics
nice.
scene like?
Yep.
It's decent. Nowhere near Silicon Valley, but you can get decent jobs. Mm-hmm. My one complaint is the pay. Like in Silicon Valley, the pay is reasonably. It compares well to the cost of living, or much better than Vancouver. In Vancouver, you probably make about half as much as Silicon Valley, but the housing is just as expensive, which is really annoying.
Right.
Oh, okay.
And are most of the jobs in the centre of Vancouver? Is there like a business hub where it all happens? Or?
Most of the electronics jobs, at least the ones I've been at, have been more in the suburbs,
Right.
rather than in the downtown core.
Yeah, we've talked about that kind of stuff before, Dave. Right? I mean, like
Yeah.
just like that's where the factories can be built. That's where the
That's where you can get more space cheaply. Yeah.
exactly.
Yeah.
Yeah.
Exactly.
What about kind of industries are up there? I mean, in general.
Let's see. There's a lot of software stuff. There's EA is here.
Oh.
Oh, right. Yes.
I think it's Microsoft, Amazon, eBay offices.
Oh, so it kind of bleeds over from
It sort of bleeds over,
Seattle.
yeah.
Okay. Interesting.
In terms of electronics,
So those companies need to have a physical presence in Canada, so they just hop over the border to Vancouver. Is that the
that seems to be the case.
Is that the city of choice?
Yeah, I think they also do it for something to do to get foreign workers in, is what I've heard.
Oh,
Oh,
yeah.
They get them to
Right.
Canada, then they get them to the US.
That makes sense. Yeah, immigration to... I know a couple people who kind of did that route. Like, I talked to people that are from other countries in California. They say they came in that way, too, as well, which is
Interesting.
great. Yeah. Cool.
But there'll be a wall soon, won't there?
Oh, please.
Between the
Please,
Canada
Dave,
and you.
don't stoke my angst.
I have to push the buttons.
Oh,
Anyway,
God.
so you've worked as an FPGA engineering physicist. Ooh.
That was, that's one of their
Fancy title.
interesting titles.
What does it mean?
I'm actually not sure what it meant, but it was just...
It sounded impressive.
when your project doesn't work, you drop it, and then you measure how long it takes to hit the floor, and you're like, yep,
Yep. how badly
gravity
it
is
breaks.
measured at 9.9 meters per second. Some margin of error. We're fine.
Yeah.
Engineering physics for the win, yes.
That's right.
Yeah, so I started in doing power supply design at Delta Q, which is a golf cart battery charger manufacturer. So working like 1 kilowatt range power supplies.
Nice.
Oh, right, serious business, yep.
Yeah.
Yep. Then I moved on, actually from all the stuff I'd done with the camera to this company called Verisant. They were doing this skin cancer detection system, which was sort of a laser Raman spectrometer that basically shone a light on your skin, looked at the spectrum of the reflection. I was doing the control electronics for that.
That sounds cool.
Got it. Was there a lot of red tape because that was medical? Although that's just like skin detection, so it's
wasn't
not
too bad.
really that medical. It's not like an implant or anything.
No,
so.
because it wasn't. We didn't have FDA approval. That was a big thing that we never really got done before I left.
Right.
But apparently, it's an order of magnitude more difficult to get approval in the U.S. than it is most other countries.
Right.
Yeah,
Like we had European, Canadian. I think we got Chinese approval.
Yep.
Yeah,
Yeah,
but
FDA
US
is just
is so
that's a
hard.
terrible process. I think Alicia and Chris have talked about that before on their show about like just the paperwork and all that crap you have to do.
It's not necessarily a bad thing, though, is it? But does it hinder like startups and stuff like that?
It probably does. Especially this is not
Yeah.
really. Like, it doesn't endanger anyone's life, so it's
No, that's right.
obviously
It's
why
just
it
a
has so
skin
much red tape.
detection. Yeah.
Yeah.
That's
So
right.
I had a friend that worked at a sanitizing thing where it was just like a steam sanitizer, and he talked about how it's for like medical tools and stuff like that. But he said the interesting thing is that you just can't change the code, right? For something that like is so made
Once
to
it's
be
been
changed.
vetted,
Yeah, that's
Yep.
that's one of the big
Yeah,
downsides.
like whole new approval for every code change, which is
right.
just ridiculous.
Yep. Have you been following the Theranos, if that's how you pronounce it, Theranos debacle?
I don't believe so.
Oh, Theranos. Anyway, we won't go into that. Google it, people. And yeah. They're going to make a movie about it, apparently. Or they did. They were going to make a movie about how this medical tech startup was valued at billions of dollars, and then it just completely
Oh,
collapsed.
that one. Yes, I heard of
Because
that.
it was a fraud. It was a fraud.
Yeah.
Yeah.
And it's like
Oops.
they got it so far as a fraud.
I know. It's brilliant. Yes. A round of applause for Theranos.
Yeah.
Faking it until you don't make it.
So in these things though, like so you were doing so almost all this is FPGA. Well, you said this first one was power, but
The first one was power. Then
Yeah.
I moved on to it was just sort of designing like a control board. It was like a touch screen with an FPGA running an embedded processor, and it talked to a bunch of things like a laser and a camera, and it had an embedded PC and everything.
okay.
That was
So-
interesting.
Got it.
All self-taught on that side of things, like the FPGA side of things, or what?
Pretty much, yeah. That's all the stuff I learned when I said, screw it, I'm building my camera.
Right. Okay.
That's right. Yeah.
That's always the way. You have a project, and that forces you to learn stuff.
Yes,
You know,
so
you
yeah.
have a goal. Yeah.
Not just,
works every time.
you'll bang this information into your head in school without telling you what it's used for. No,
Yeah.
do something.
Exactly. No, a
Real.
real app.
Yep.
That's right. Now you stopped working in July. So are you now full time
I'm
at
pretty
Cron
much-
Technologies?
Pretty much doing this full time. Yeah, I've sort of slowed down
Yep.
on some contract work I was doing, which sort of,
Oh,
that sort of
right.
lines up
Okay.
with
It was
this.
contract, was it?
Yeah.
Right. Yep. So that would you have been able to do this Kickstarter if you had a full-time day job, 9 to 5 day job?
It probably would have been delayed into the new year, and I would have been pulling my hair out the whole time.
Yeah, right.
Yeah, it was back when I was actually doing more full-time work. It was really, really stressful. I was not in the best situation. I really had to reduce some load somewhere.
Yep. Yeah.
Got it.
Yeah, it's tough too. I mean, just like the mental load of, like if you're working all day, working through problems, and then it's not like this is small stuff when you're getting home either, right? This is tough.
That's when it's not fun anymore, and that's when when you sort of just want to quit. Yeah.
Yeah.
Yep.
That's too bad.
Well, let's talk about the camera and the Kickstarter and everything else, shall we? You're currently up to 359,000 Canadian, those weird Canadian dollars.
Weird Canadian pesos.
I love Canadian dollars. That's how I used to go gamble when I was 19. 1.6 Canadian dollars to the US dollar when I was 19.
Yep.
And your goal was 65,000. Now, was that an artificially low goal so that you could, so that it would help the psychology behind the whole hitting the target kind of thing with people?
I guess a little bit. I mean, I can sort of build these in any quantity. I can just build a batch of whatever size. I figured I didn't really want to do it if it was below about 20, though, just because
got it. Okay, so you priced at that. Right.
Yeah.
Got it.
And how many have you built so far?
I've built 12 of these current prototypes for testing and for send out for promotion.
Okay.
And these aren't just prototypes either. These are basically pre-production, really?
These are basically the final production version.
Yeah.
Nice.
Wow.
That's great.
And that is so unlike most Kickstarters. It's like I've got a 3D render and a breadboard, and
yeah, like most Kickstarters launch like with the I have on the Kickstarter page there's a picture of the prototypes, and there's a 3D printed case version. Most Kickstarters would probably start with that.
Yeah. Step 1, get injection molding made. No, wrong.
If the quantities keep going up, I'm going to have to start looking at die casting rather than machining.
That is what I want to talk about. At what point, at what quantity of volume do you hit the valley of death, or whatever you want to call it, where it's uneconomical or too hard to make them yourself in using your current techniques? Not enough money to yet commit to, having Foxconn in the US make them for you. Foxconn in China make them for you.
That's sort of a tough one. In terms of making them in-house, especially one of the most difficult things is the cases, because my CNC machine I'm pushing it to the limit. You still make them
yourself?
I made those 12 myself, but I probably wouldn't do it again because my CNC machine is old. It took a long time.
Right, but you could just farm that out. You have the files, right? So
yes, I'm just going to farm that out.
Right.
And so why die-cast versus CNC then?
That is probably going to be a decision based on the quantity. I'm thinking, just based on some quotes I'd gotten, something around 300 units might be the breaking point for getting a die-cast mold made.
And you currently got 121 backers.
Yeah, I think actually, in terms of actual cameras, it's like 75 or 80. The rest are just lower-level rewards.
Oh, right, of course, right. Okay, so you're about a third of the way there, maybe a quarter of the way there. And what does a die-cast mold cost, roughly? What order?
In China, ones I was looking at were something around, for this size, would probably be something like 30 to 50 grand.
Oh, okay. So
but
serious money.
Once you've got it, it's like $5 or $10 per part, so it's dirt cheap.
Right.
In terms of CNC, I was quoted the entire case set is something on the order of $100 per set.
Oh, okay. So 20 times less for a die cast.
Something like that, yeah.
Yeah, but you got to amortize all that then.
No, of course, for your 50,000.
Could you? I don't actually know. I should probably know this, but what is die cast process? I don't even know what that looks like. Is that like poured in or what?
It's basically just like injection molding, but they inject metal at high pressure instead of plastic.
Oh wow!
It generally
results in... Is it a high temperature too, or is it just high pressure?
I think it's some maybe 100 or 200 degrees Celsius above the melting point. But it's injected under pressure so it can get into all the little crevices before it solidifies.
Huh.
Got it.
That's crazy.
Mm-hmm. Yep. But they can churn them out for, cheap as chips.
Those Hammond project boxes, are those like die cast?
The metal ones are die cast.
Yes.
Yeah.
Okay. So that's like a good example.
Some are extruded, but most are the bowl shaped ones are die cast.
Yeah, right. The ones that have like the screw on flat top type things. Yeah. Okay, well that's a good reference then.
Is the finish better with a die-cast one?
I would say no. It's hard to beat machining as a finish.
Oh,
It's like
okay.
powder coat it then, right? I mean, you could always do that.
Oh, right. You could powder coat it, and then you'd have the nice smooth finish.
Although die-cast
Right.
offers several advantages, and you could like have recesses for nice rubber grips and things, and you can do much more advanced shapes that would have a much better feel in your hand.
Oh, it's like
Okay.
overhangs and stuff like that. You could do more
Things that are
fanciness
very
with that.
expensive to do on machining are much more.
Oh,
doable.
curves, yeah.
Yep.
Yeah, I guess you could do that too.
Compound curves. Yeah.
Yeah.
Got it. Now, if
You
you
get real
were,
fancy.
let's assume for a second that you were one of these, idiot Kickstarters who have their 3D render and, not much else and not much of a clue. You haven't been working on it for 10 years. If you then got your $1 million on your Kickstarter, how long would it take to actually design this sort of camera? Like, if you had to farm it out to as most of these people do, they just go, oh yeah, I'll just farm it out to China and they'll design it for me. How would it? Because it's complex business. All this high speed capture stuff and storage and processing, everything else.
Yeah, if they went into it with no base or experience, it would probably take 2 or 3 years. And
So that would be if they
several
is that if
engineers.
they're hiring you, it would take 2 or 3 years, knowing what you know now.
I'd probably do it a little bit quicker, but if you hire just a typical team who had not done it before, it's probably around
Right.
that, maybe even a bit longer.
Okay.
Yep. Wow.
Yeah, that's nuts.
So that's where it pays.
The experience really pays, yeah.
Experience pays, and having a real, not just a prototype, but basically a production ready prototype, pretty much.
Yes.
That if all things fail, you could go to production with exactly what you got now, and most backers would be, entirely happy.
Yes.
So,
yeah,
are there any tweaks you're going to do?
I'm going to do a board spin. There's a few issues with the battery that I didn't expect. The battery, some of these batteries
Pain in the
I'm
ass
using.
battery.
Yep. Some
All
of these
this
batteries.
high tech, high speed capture stuff, not a problem. Batteries.
Yeah. Some of the most annoying things, the hardest things I've dealt with. One of them is the battery, which some batteries don't report voltage properly. So I expected them. The one I reverse engineered to the battery BMS protocol on. Reported all that, and then the new ones I got didn't. So that's why the prototypes currently don't have battery monitoring working.
Yep.
Yeah, so
I noticed that in my prototype. Yeah.
I hear you can get really low cost Samsung Note 7 batteries these days.
Oh yeah, the problem is in 5 years can I still buy that?
Oh well, I meant they'll explode. So
It was smart. It was smart to use an off the shelf. Existing battery pack that's pretty much always going to be available.
right,
Yes,
I
so
agree.
this
That
is
was
used
shape
on
and size.
Modern DSLRs, like it was like 20 megapixels. That's going to be available for a long time.
Yep.
What else was difficult? The other thing to do with the batteries, the contacts for the battery is
like fine metal?
Yes.
yeah.
How did you get those?
The ones in the prototypes are just a certain spade terminal. that
Oh,
happens to
okay,
fit,
right. It just happens to fit. Okay.
Yeah, and that's what I'll have to use for now. But if the quantities are high enough, I'm going to actually spring and have a custom connector made because there's just no off-the-shelf connector that fits these batteries.
Right.
Because it's like a blade contacts, 2.5 millimeter pitch, and there was one on Alibaba that was close enough, but I emailed them and it's like, no, sorry, we don't have that anymore.
Oh,
Yeah.
damn it.
But the current
Because you could probably get a bulk buy. If you found one, you'd go, right, I'll buy 100,000 of those, please.
Yeah, but yeah, the terminals work just fine. I just have to make up a jig to position them properly when building them.
Got it.
So I didn't actually get a chance to watch Dave's teardown yet. Could you
I haven't
kind
done a
of?
teardown. It's a review.
It's a review. Oh, I'm sorry. So David, could you just kind of walk us through like how many boards? What's the assembly like? I mean, is it like stacked boards or is it single board?
It's essentially one main board with either direct connectors or FFC cables going to subboards. There's one for some connectors, one that has like power switch and microphone, one that has the image sensor, and one that has an encoder and speaker on it. Yeah, I designed it specifically to be really easy to assemble. I hate crimping wires. I hate buying expensive crimpers.
Yep.
So I've designed all of those out.
That's great. That's really
Awesome.
smart. And so it also it has the monitoring screen on the back, so that's why it needs the speaker. That's why it needs some of the flat flex, like you mentioned. Like these are consumer level type things, right? I mean, these are
they're all super low cost, super easily available.
Yeah. So you're designing for just whatever is the most common you can get, or how did you decide?
Pretty much
stuff?
what's common, what makes it easy to assemble. Yeah, just to try to make it easy, make it not a pain to get out.
Okay. So so you were talking about quantity for the boxes. And getting to the die cast would be nice. Any chance you're getting to quantities on the FPGA or any chips you have on board? I mean,
the quantities for decent discounts.
Well,
are you getting any kind of discount at all?
We're only talking about a couple hundred. Yeah, there's not going to be any huge. There's not going to be any huge discounts on parts. In terms of assembly, I have a supplier in China called Our PCB who has been very good so far. I think for these boards, like the main board on this, which is about 1,000 parts and about 130 unique BOM line items, it's about $100 assembly.
$100 for the assembly.
That was for
That's pretty
quantity
good.
12, and it gets down to $100 each for assembly quantity 12.
Yeah.
And then it gets down to
that is cheap. That is cheap.
And then it gets down to, I think it was 60 if I ordered 100.
That is still seriously cheap for that sort of low volume, and we're talking serious parts here. I mean, these are loaded on both sides. We've got high density.
Got like a 600 pin BGA,
600
700
pin
BGA.
Yep.
That's fun.
Serious business.
Yeah.
So that's seriously good.
Yeah,
pricing.
I've been really impressed by them. Like they said, oh, we failed X-ray inspection on one. We're reworking. We're holding in a few days. I got them all back. There was only one rework required, one solder bridge on one cap. So I was really impressed.
Yep, that's awesome. Now,
this is really nice.
Architecture-wise, I'm gonna please correct me if I'm wrong here, but image sensor, 16 LVDS lines coming out.
Yep.
That goes into a EPC5 FPGA.
Yep, that's right. Yeah, ECP5 FPGA.
What is that? Sorry,
Lattice ECP5.
Oh, it's a lattice part. Okay.
Yep.
Lattice.
So why
we'll
did you
talk
choose
about that in a sec.
Oh yeah, sorry. Yeah, that's good to keep going.
Right.
Sorry.
So people can visualize the architecture. I'm making hand gestures at the moment of the signal flow, and that into the FPGA. The FPGA does all the high-speed decoding of that and storage into the DRAM, the high-speed DRAM.
Yep, that's right.
And then it encodes a video format, which we'll talk about, and sends the video format to the processor, which is like in a standard video format, which is a TI DaVinci TMS 320.
Yeah, DM8148.
DM81, they've got 10 million variants.
Yeah,
Yep. We'll talk about that. And then that does the conversion to H.264 and drives the LCD as well and everything else, user interface.
Yep. Yeah, it runs Linux, drives the UI, yeah.
Yep.
Nice.
Got it. And that's pretty much it. It's a 2 main chip solution.
Yeah, really simple.
3, right? Because the sensor.
Sensor, yeah.
Oh, well, the sensor, of course.
Yeah, of course.
Okay, so let's start with the sensor. Which sensor are you using? Was it easy to get? Is it in low volume, all that sort of stuff? How did you
it's
acquire
the Luxima Lux 1310.
Yep.
Yeah, it's surprisingly easy to get. I really have to, hats off to Luxima. They're really easy to deal with, even as a little guy.
Nice.
Like, I think some of my emails to them were even copied to, I believe, the guy who designed the silicon on the sensor.
Oh, wow.
Yeah, so support was really good.
That's great.
Wow.
Yeah, I wish all semiconductor manufacturers were so easy to deal with.
That's it. Is that because they're small niche that they're able to?
Yeah, it's a pretty small company.
Right. Okay, they obviously don't fab them themselves. They fab out the sensors to.
Yeah, they come from Taiwan. I think it's one of the manufacturers out there.
Yeah, I don't know anything about camera sensors, so
yeah. Who would manufacture the camera sensors? Would it be Sony, or would it be like you can't just go to one of your regular chip fabs and presumably and fab
I'm actually not sure about that.
Interesting.
There's probably some special process required to make efficient sensors, though, I would imagine.
Oh, totally, yeah, I'm sure. Which I didn't think your regular chip fab could do, but I could be wrong. Chris, you're from a
I
chip
know I
fab.
should know this stuff, but I don't.
Yeah, I know.
I don't.
But you don't.
If anyone
Yep.
knows, maybe leave a comment.
Yes.
Anyway, so you were able to get those parts in onesies, twosies. Did they give you free samples, or did you have to pay?
No free samples. I did have to pay for them,
Right.
but yeah, it was easy to
Right.
deal with.
Nice.
Yeah.
And did you have to sign an NDA or anything stupid like that?
Nope, the datasheet's not public, but you just email them and they send it to you. And other people have had the
Brilliant.
same. Yeah,
That's great. Win. Oh, we'll have to get
that's
them
how
on the
to
show,
run a
mate.
semiconductor company.
Yeah.
So
Well, that'd be interesting, actually, to get the chip designer on
Get
the show.
them on, yeah.
Talk about CMOS sensor design.
David, what about the thing I never understand about the sensors is so it's 1.3 megapixels, which is a. Can you explain like just the measure of what that is versus the resolution versus what the output image can be? Because I never quite. It seems like it doesn't seem to match up with whatever's coming out versus like they get oversampled or something.
No, well, yeah, the imager or image sensor obviously has an array of some size, and yeah, you can either read out that full array and get the full resolution video out. It's just usually sampled like, from top left pixel to the right and in a normal raster fashion. And in these high-speed sensors, you can usually also window it down to smaller resolutions and read the same pixel rate, so you get a higher frame rate. So that's how we get the higher frame rate.
Right. And that's why you get the 600 by 96 resolution or whatever it is for your 21,000 frames
Yes.
per second. So it's that long landscape narrow
Yes.
thing. Now, I've always wondered why, okay, you window it down, but why can't you have like separate windows and then separate clocks out? Is it just the architecture of how the sensor works, or?
Yeah, there's basically as you read out the chip, you select which horizontal row you want to read out. That gets put onto each. There's in this case is the imager is 1024 pixels, 1280 pixels wide.
Yep.
So there's 1280 parallel lines. When you select the first row, those 1280 lines get driven with the different voltages for each of those pixels.
Yep.
And then there's muxes that select groups of 16 to go off to the ADCs.
Right.
And I think in this sensor, the ADCs run at 90 megahertz, and there's 16 of them.
Oh my god.
Why can't they just increase the number of ADCs? Why can't they just have like 1,000 ADCs on there and have 1,000 separate lines coming out, and you'd get 100,000 frames per second?
Some cameras do something like that. Some other sensors
Right.
they make have column ADCs, which is just one ADC per every column.
Per column. That's what I'm talking. That's exactly what I'm talking about.
The
Yep.
downside of that is you can't trade horizontal resolution for speed because you're limited by the rate of those ADCs, like one line every clock.
Right. Interesting.
So did you play? I'm looking at the data. I'm looking at the. We'll link in the thing to the Lux 1310, but it says frame rate up to 1 million frame per second at 1280 by 1 pixel.
I'm not sure where that number came from because I can't get it to run at that rate.
It seems really.
By
What
one
did you even do
pixel.
with that? Like
LA.
that line. There it is.
Yeah, that might be useful as a street camera if you just want to see the horizontal motion of things.
Oh, okay.
Like
Yeah.
you can buy special
Yeah,
street
right.
cameras that are just some
Yeah,
width by
single
one.
pixel. Yeah, you can buy a one. If you can buy a 1 pixel sensor, 128 by 1 pixel sensor. They use them on scanners and other applications like that.
Awesome.
So,
Yeah, document scanning, things like that.
Yeah, document scanning
that makes
and
sense
stuff
then
like
too.
that. Yes.
Yeah, so if you want to frame, if you want to scan 20,000 pages per second, you're in good shape.
Yeah.
Good luck with your motor drivers.
All
That's
right, so sensor. Any thermal issues with the sensor? What it is? I think I haven't got the data sheet. It draws a couple of watts or half
Something
a watt
like
or
that,
something.
yeah. I initially,
2 watts at full resolution.
2 watts.
It says.
Okay, at full res.
yeah, when I built the first camera, I was thought, this might get somewhat hot, so I put a hole in the back of the board to connect that directly to the back of the sensor, and that was very useful because, yes, it does definitely need heat sinking to keep it at a reasonable temperature.
Right.
So in the camera,
And
there's this
what
little...
happens if it gets too hot?
I've run it at full clock without heat sinking, and it was okay, but on one sensor, when I was first bringing up this new camera, I forgot that there is an internal PLL So I accidentally
right.
put 270 megahertz into it when it should have been 90, and that sensor now has some dead lines on it.
Oops.
Yeah.
See, now could you capture the smoke being let out of the chip at that super high rate? Because then it's like a recursive thing, you know?
Could. If it wasn't actually any smoke, but you could.
You never know.
So
man.
if the chip could capture smoke release from its own sensor.
Yeah.
You'd
That'd
Then
be
you could line
awesome.
them all up, and you could just destroy
Yeah.
like thousands of dollars worth of cameras at once, you know?
Nice. Now, how does this perform in light-wise? Is it particularly good? Is it particularly meh?
It's reasonable. Like, it's better than the previous version of this camera used another sensor called Lupa 1300-2. That was about, it's twice the pixel size, and it was half the speed. But this new sensor is about the same sensitivity, even with much smaller pixels. So I'm actually pretty impressed with it.
Nice.
The sensitivity, how do I describe this in terms people will understand? To shoot in 60 frames a second, like 1/60th of a second exposure, takes about 400 lux to fully saturate the image sensor.
For those who want to know,
I was gonna
that's 400 lux is average office lighting,
Yeah,
probably.
that's good. Yeah.
Yeah.
Yep.
Okay.
Yeah, so with no gain, you need about something on the order of 8 to 10,000 lux to run at full speed and
Which
set
is-
to fully saturate.
How many
That's
light bulbs?
it.
Is it like studio lighting kind of thing?
Some pretty good studio lighting, yeah.
Yeah. Or how about Ben did a demo video too, and I saw that one. Sorry,
That
I
was
didn't
cool.
watch Dave's.
Yeah.
But I saw that. So he had like a 600-watt bulb or something like that, or something, wasn't it?
Yeah, 600 watt incandescent, yeah.
Yeah.
Yeah, the lighting, unless you're shooting really high resolutions, it's not too bad. Like, you can just about do, in the decent lighting I have in the garage with a little bit of gain, you can do decent shooting just in the room lights.
Okay.
Right.
But to get really good
But
images, you need lots
yeah.
of light.
So, and
Yes.
what is the physics reason for that? Is that just the
It's just the number of photons hitting the sensor.
so just charging up the capacitors?
Yeah, charging up the capacitance. There's just a physical limit there that you just can never get around.
And of course, you can increase the gain, but then you get the noisy image.
Yeah.
You get that pixelated noise on your image. That's just
So it's like a low-level DC problem, but just done really, really quickly.
Yeah, it's just like trying to capture the most data you can in the least amount of time. The less time you have, the less you can capture.
Yeah.
So it's the photon to noise ratio. Is that the
Yeah, it's just
problem?
the size
It's not
of
the correct term, but
Yeah, the size of the pixels, their quantum
Yeah.
efficiency, which is what percentage of photons actually get turned into electrons, and how long your exposure time is. Those three things sort of define the sensitivity.
Now, what is the difference? This is a CMOS sensor, but a lot of people are familiar with CCD sensors. Have you
Yes.
used those in the past?
I've used
and what's
CCDs.
the difference?
Yeah, I've used CCDs in the past. They are better in a lot of ways. A CCD is quite different. A CCD sensor works by having this. You have a silicon substrate with these little electrodes across it, and you set the voltage on these electrodes to create like potential wells, so that when
So they have physical wires, physical little.
little wires going across the chip,
Right.
and then different doping done in the silicon, so that when a photon hits the chip, it knocks electrons free, and those electrons are just sit there, held in place by the electric field of these wires, and by however the chip is doped. And then you pulse these wires on and off in a sequence to push the electrons down the chip. And you push them off to the end row, and then on the end row you push them off to the side, and off the side to an ADC.
That sounds tough.
Yeah, it has issues, but it generally has pretty good quality, like very good signal to noise ratio.
Do they still use CCD for like space and satellite?
And super
space
high
probes and stuff, don't they?
Yeah, we used them in at Verisant for this camera because the image sensor was actually cooled by a Peltier device down to like minus
Right.
40 degrees Celsius to reduce the thermal noise.
Wow.
Yep.
And the CCD really works well at reducing noise when you reduce temperature, but CMOS
Hence,
doesn't work that way.
space.
Yeah,
Space is cold, so yeah, you don't need to cool
Yeah.
it down.
And on
You
your
can
telescope-
just expose the back of it to space, and then boom.
That's actually not true, Dave.
Yep.
That's not true.
No.
No. Space is terrible at cooling things. Have you not read about space?
True. Oh, of course. Yes, of course.
It's the vacuum. Yeah.
Yes.
But either way, it's probably still something like that, yeah. I don't know why it would be good in space, but... Space is not good at cooling things. I've learned this from sci-fi.
No. Anyway.
And those are harder to manufacture, though?
I believe, they take a very different process. I believe, CMOS sensors are a much more standard process that can be done on normal semiconductor equipment. So that's why they're sort of preferred. Mm-hmm. And you can also integrate all your control electronics, control logic, and ADCs right on the chip, where you can't do that with CCD.
Oh, interesting.
Got it.
Cool.
All right, so we got our sensor. You hook up 3.3 volts, 1.8 volts, analog and digital, and bingo, out pops the magic data from the LVDS lines.
Right.
Yes.
So these go into your
those go into
FPGA?
The FPGA. Those are.
Let's talk about the FPGA.
Sure.
Why lattice and why not
Actually,
the other two biggies?
Let's see. I'll start out why I chose lattice initially. And that was because back at the time, which was 2011, I think, or 2010, it was the only vendor that supported full 64-bit laptop SODIMMs or computer memory in a low-cost FPGA, like below $1,000.
Interesting, right.
Yeah, since then, they've all, most of the manufacturers now support that. But
So they've got hardware support in the chip for those SODIMMs. So doing all the refresh and the everything else.
Not quite. They have hardware accelerated accelerated certain functions because DDR3, the minimum clock speed is 300 megahertz, which is really difficult to deal with.
Oh, okay. I didn't know there was
That's one of the really difficult things.
Okay, minimum, right.
Yeah, DDR4 is even worse. It's about a gigahertz.
Whoa. Ooh. Right, which people might be thinking like, oh, well, there's lots of processors that do that, but a lot of FPGAs don't need to go that
Getting
fast. Getting
I/O to run at that speed is a huge challenge.
Yep.
Right. And power draw and everything else, right? I mean, that's crazy.
Oh, yeah.
Yeah.
Yeah, so they have these special output drivers that buffer 2 bursts of DDR into 4 bits wide to get the data rate down to 1/4, so you can actually deal with it in the FPGA logic.
Yep.
Oh.
So how much of a hassle was it to get the DDR working on this FPGA? Was it easy?
The old one, the ECP3 I was using in the previous version, was easy. The ECP5 was much more difficult because it's a new chip. I think I might be the only...
Does that mean they didn't have example code?
They had example code. They had example code that didn't work.
Oh,
great! Yay.
Ouch.
Yep. It took me almost 2 months to get this working. I might be the only person, even including Lattice, who has this working properly with 64-bit bus.
Wow.
You should sell it back to them and, make your money back, I'll give you this, you give me the chips for free. That's what you say, right?
Yep.
I should try to, yeah.
What is the relative cost on an ECP5? I mean,
I think for this one, it was the ECP3 I was using before was about $200.
Oh my god!
This is down to I think about 70 or 80.
Okay.
Mm-hmm.
So it's not too horrible. Like it's half the cost of anything else that will do this. Do a similar thing.
Yeah.
And how many pins did you need, and were you forced to use a high pin count package just because that's all they had?
Oh, Dave's touch point.
I had to use the highest pin count just because that's what you need to run the 64-bit memory bus.
Wow.
Right.
There's a few pins free. Actually, there's about 30 pins free.
Okay, so you did genuinely use all the I/O on this thing.
Like just because of bank voltages, I really strained for I/O on this.
Huh.
It's pushing this low end FPGA pretty far, but it's the benefit of saving like $120 is pretty big.
So what about the? Do you have an idea of the? So I only have a relative measure. I know some of the families in Altera and Xilinx. Do you have what does this usually compete against? This FPGA.
This would definitely be the lower end Cyclone, like Cyclone 4, Cyclone 5.
Okay. Yep.
Yeah,
but
Lattice,
the high pin count one,
Yeah, I think Lattice was going to release an ECP4, but they canceled. It was going to be higher performance, but they canceled it and then released the ECP5, which was a lower performance, much cheaper chip, but it seems to fill this market pretty well. Just the price is so much better than anything else.
Interesting.
At $200, the price is so much better.
Yeah, or at 70 or whatever. Yeah.
Did you get this first spin? Because you can't just breadboard this thing. right? And like,
Do you have that in a
you've got to
dip package,
commit.
please?
You've got to commit to like what a 6 or 8 layer board or something to
Yeah.
fan out all the stuff, and we'll probably talk about that. And like, yeah, did it work first go? Did you have
Yep, it worked
issues?
first
What?
go. I made a few mistakes that I was like, wait a minute, that's not right. Oh no, I swapped those two. I was just gonna brick the whole thing, but no, I swapped the two of the bank voltages, 1.5 and 2.5 volts.
Yep.
But luckily, it still works.
No, okay.
All right.
But yeah,
rugged
this
process.
next revision, I'm gonna correct that.
God, so the camera I've got has got a wrong bank voltage.
Yeah, the one of the 1.5 volt I/O banks is driven by 2.5 and vice versa.
That's hilarious.
Yeah.
How many total? Because I always hear about the promise for FPGAs of like they're like, oh, we're reducing our stuff, and then I see designs for these fancy FPGAs, and they're like, oh no, there's like 8 power rails. So how many rails
Yeah.
do you have?
Let's see. There's 1.2 volt core, 2.5 volt for some analog stuff like PLLs, and beyond that is just whatever I/O you need. So in this case, I think there's 1.5, 2.5, and 3.3.
Okay,
But you need an additional 1.1 for your processor as well,
Yeah,
don't you?
the process. Actually, no. The FPGA is now 1.1 volts. That was the old one was 1.2.
Oh, okay. Right.
Yeah, the
Okay, so
processor-
you're able to share that with your processor.
Actually, no. The processor
No.
needs a variable supply between 1.2 and 1.35, depending on what clock speed you're running at, which is annoying. So I need a whole other regulator for that.
Really?
Yeah.
It needs a variable source.
Most of these system on chips, like certainly the ones in your phone, the power supplies are variable voltage so they can get the best power efficiency.
huh?
So when they
Right.
clock down the chip, they reduce the voltage.
Oh, okay.
So, like,
and you've got to
dynamically
handle
clocks
that
down? I
in
mean-
software?
Like-
Yeah. In this case, I just have it locked. I'm not so concerned about power here because everything else is so power
Yeah.
hungry. So I just leave it running at the max 1 gigahertz and 1.35
Right.
volts all the time.
Okay.
But in a software
Got
update, you could potentially implement the proper voltage scaling.
And then do you need another? Because DDR requires the half scale voltage. Is that right?
Yeah, there's a dedicated regulator that produces the 0.75 volt termination voltage.
Okay. Yeah, that always trips me up too. I'm just like, that's crazy to me. That
Yeah, DDR is such a pain to deal with. I wish they would just make it LVDS pairs. Like Rambus had RAM that was out. It was beautiful, but no one adopted it.
right? Because
Right.
Rambus is
Yeah,
this
because
shit
Rambus.
company with terrible licensing. Yeah.
Yeah.
Yeah, so your mid, can you tell us about that bias in for a sec? The mid rail bias in?
Yeah. So at the end, let's just take an example of the address bus that runs from the FPGA to all the RAM chips. And this is a pretty long, like, even on those little SODIMMs, the total trace length is like 6 or 8 inches.
Yeah, it's not much. Yeah.
And that's, at the end of that, you don't want reflections from your high-speed signal, so you put a termination resistor. And to get the minimum power, you connect that termination resistor not to ground or VCC, but to half of VCC. And that minimizes
So
the
it's
power
only
dissipation.
for a power dissipation reason, not necessarily for a reflection reason.
Yes, you could terminate them to any voltage. Well, there's
Right.
some other issues, like if you terminated it to ground, it would pull the DC level down, and then your thresholds would all be all messed up.
Yeah.
Yep.
Because it also uses the 0.75 volts as a reference for the input buffers, so they know exactly where half VCC is, so there's minimal variability.
Right.
Now, did you use resistors for this, or did you use dedicated end termination chips? Because you can actually get end termination chips for these things. I've used those in the past.
Termination is all done on the SODIMM, so I actually don't have to worry about that.
Oh,
They just have
okay, of course.
resistors.
Right, yeah. Right.
Wait, when you s-
yes,
so
because
s-
you're using the SODIMM module, yeah.
Yeah.
That's like the plug-in, like there's a header and you plug in. You can like swap out the memories. Then is that right?
There's standard SODIMM sockets.
Huh. Well, that's nice.
Exactly like your exactly like the PC you're using, Chris.
Yeah, like
Same
it's like
thing.
the laptop style.
Like a
It's not like
laptop,
the
yeah.
wide one, right?
No, well, no,
Yeah. Huh.
desktops. Yeah.
Well, that's nice
But
too
if you
then. So
had to-
for
but if you
sourcing.
went away from the modules, you would have to, and you use the DDR chips directly on your board, then you would have to roll your own termination solution.
Yes. It's not too bad. It's basically just a whole bunch of resistor packs to VTT.
Yep.
Yeah.
Got it.
Can we step back to the sensor talking to the FPGA real quick?
Okay, sure.
So that's LVDS, and I've one sensor project in the past, or image sensor with an FPGA before, and it was using SerDes stuff. Those are different, right? Why was it just based on the output of this particular sensor? Like why one or the other? Are there advantages or what?
In this case, there's not enough SerDes channels, so we just use the input buffers on the FPGA. But you could use SerDes as well if the FPGA has enough of them.
So then
Also, because of the format, the data format, it doesn't really line up with SerDes, so you have to do some bit of deserialization logic in Fabric to get the proper to sync up the data.
I gotcha.
For those who don't know, FPGAs typically have a SerDes, which is a serializer, deserializer, hardware embedded on some of the I/O pins, not all of them. So if you've got something that you want a serial input that you want to convert into parallel, then it can do that for you without in its own dedicated hardware block, without you having to do it in your FPGA fabric. So
yes, and it's also usually much faster.
Faster, yes, exactly. So, but you're saying there weren't enough, so you just didn't use any SerDes?
Yeah, and also the chip that
Wow.
the chip that includes SerDes costs quite a bit more. So it's best not to.
Right.
Yep.
Okay.
Yeah, it's like an upsell they do.
Yeah.
Like if you look at the
Right,
comparison
yeah.
graph. Right.
Yeah, in terms of
Yes.
like signal integrity, the LVDS is dead easy because it's a
Yep.
nice terminated differential pair. The difficulty is really in the RAM, because that's like this multi-drop bus still running at a very high speed.
Yeah.
Buh.
And
Yeah,
that's
that was
would you say
as
that's
long
running?
as you
That's a gig, you said?
the DDR runs at 300 megahertz DDR, so 600 megabits per second.
Yeesh. Yikes.
It's
yeah.
as long as you follow the guidelines, it seems to be okay.
And on the FPGA front, with all this integrated hardware, for those who don't know, I think we've talked about it before, the dream of FPGA was that it was just a fabric, a sea of gates, and that was it. And you could do whatever you want. You could include the SerDes in there, you could include a processor, you could throw in any hardware, UART, any hardware you wanted into this thing. And then they realized, it doesn't work so well, especially at high speed. So we'll put dedicated hardware blocks of real silicon in there for these SerDes and other, processors.
Yeah.
And ARM processor, it's not very quick when you implement it in the FPGA fabric.
Yeah, like just as
so
example,
we'll put in an ARM core.
when I had the old version of the camera had a soft core, and that was taking up
processor,
nearly 40 or 50% of the FPGA. But on this current one, where it uses a separate
And
CPU,
ARM soft core? What soft
no,
core
it was just a microblaze. I think it was the Xilinx microblaze.
Xilinx microblaze, yep.
And the new one, where doesn't have the soft core, the whole project is only using up about 15% of that FPGA.
Wow.
It's so much smaller.
But you still had to buy that expensive couple $100 FPGA because of the I/O count, right? Or the speed, or whatever
and
the
I/O count,
features. Yep, right. Bummer. But you're only using 15% of the space.
Yeah.
That's great though.
Yeah.
That means you can do field upgrades
Yep.
later.
I
Yeah.
definitely plan there's some better demosaic algorithms I want to implement. Those are going to take up some, but it's nice to not be fighting, trying to cram every little bit on.
Yep.
There was one job I'd interviewed for, and they were saying, "Oh, we have this camera out there, and the FPGA is 95% full." I was like, "No, I'm
Got
not
up and
touching
walked out of
this."
the interview.
I'm not taking that one on.
Yeah.
I remember I had to roll my own by hand. I had to do my own place and routing by hand to fit everything in to a CPLD. I route it like I did the
back
auto
in your day
compiler
was what,
and it
20,
said,
20 gates, right, Dave? You just
yeah, right.
Back when you actually could do that.
1,000 gates. Yeah, a couple of thousand gates. And yeah, you could place and route by hand. And it was, and I fitted the damn thing in. Damn it.
so
Screw you, Lattice.
David, what
got
kind of stuff is actually inside then? I mean, so you have 16 parallel paths of data coming in.
Yep. So those get
yeah.
Serial
serial,
paths, and then
those
converted to
basically-
parallel.
Yeah, those get clocked into a shift register that converts them to parallel. Then they go into some FIFO buffers, and that gets dumped.
How big are the buffers?
They're pretty small. They are 256 bit wide, and they're I think 512 words deep.
And why do you need the FIFO buffers?
That's because when the RAM has to be accessed by multiple things, it has to be accessed by the
Got it.
logic that writes
Yep.
the data, it has to be able to read out for display, it has to be able to refresh. So you always have to be able to pause, and the data coming in has to go somewhere.
Oh wow.
So if you had true dual port memory, you wouldn't need the FIFO.
You wouldn't need that, no.
Yep.
But I don't, that's not available in DRAM, so that's not
No,
really
that's
practical.
right. It's not really an option.
So, oh wow.
What else?
Yeah, 'cause this is, so like if I was visualizing the data from it's like a fire hose of data, right?
Yep.
And then you're trying to
Coming-
put it into a bucket, and then at the same time though you have
It's
to
like
have,
you're filling up a bucket with a fire hose, then you
Yeah.
have this super powerful vacuum that quickly sucks it all out, and then it fills up again, and it sucks it all out.
Wait, so so you have to pull it. Okay, so the fire hose is coming in,
Yep.
it's filling up this bucket, but then it has to go back out, and that's going out to where?
At some point, it hits a fill level, and that trips logic that starts reading the data out of the FIFO and dumping it into RAM.
Oh, I thought the bucket was RAM. Okay, so the
No.
bucket is
Bucket
the FIFO.
is the FIFO. Yeah.
Okay,
Right.
okay, interesting. And then
Yeah, then it gets written to RAM, and then a separate piece of logic reads out the data as specified at a certain address and processes all the display functions. Like it does some gain and offset correction, demosaics, it does color matrix, all that image processing stuff.
so, but the FIFO doesn't ever stop. Oh, I guess it's a FIFO anyways, right? So it's not really a bucket. It's like a I don't know what it would be, like a tube, right?
Yeah, it's like a tube, like a bucket. A bucket is like a stack. It's sort of the opposite of a FIFO.
Yep.
Yeah. Okay. Oh. And then it goes into the.
Then it gets read out for display. It gets read out of RAM into another FIFO, and then that gets read out much more slowly at the sort of like 60 frame per second pixel rate to be sent to the system on chip.
Now, here's the interesting thing. You actually convert it to a video format
Yes, it's
to go
basically-
between the FPGA and the processor. Now, I can guess at why you did that, because it's normally an extra step you wouldn't do. I'm guessing,
Yeah.
but because you did it because the FPGA, the processor has support for video in.
Yes, it
that the
supports
reason?
standard 24-bit
Yep.
parallel RGB video in.
Got
So as long as it's in that format, it's really easy to deal with. All the software they supply just works,
Got
and
it,
it's really
yep.
easy to develop for.
Yep.
That sounds nice.
So that was a development time decision. You know, why
Yes.
roll your own processor code to
Yeah, like that would require
compose video and stuff
need
like that.
a couple of software engineers for a year to do
Right.
that.
A year to do that, right. Got it.
Well, that's really smart then. And so, wait, so what does it take to get to that RGB24 format?
It's basically the data from the image sensor. There's a 12-bit word for each pixel, and even on the color sensor, there's only one 12-bit word per pixel. So it has to go through an algorithm that interpolates based on which color filter that pixel is. It interpolates some of the pixels around it to get the full RGB value for that pixel.
Oh,
And then
because it's
that's-
24 versus 12-bit, you mean?
Yeah, well, it's 12 bits, and then that ultimately gets converted down to 8 to be output.
Oh, eight per color? Is that the
8
idea?
per color, yeah.
Oh, okay, I see.
Now,
Damn,
can we
that-
quickly... I don't
yeah.
want to derail our nice sequential design
But he's about to.
discussion here.
He's
but,
about to.
yeah, I'm about to. So just jump back to the sensor. The sensor's available in monochrome and color, and you actually offer people, don't you, in the Kickstarter, a monochrome or color version.
That's right, yes.
What is the... why would you want monochrome?
There's a few reasons, and a lot of people actually ask that.
Yep.
Because of the color filters, to understand the color filters, Google Bayer color filter. I'm sure we'll have a link
Yep,
there.
I've done those in one of my videos, yeah.
Yeah.
It's very
Beca-
interesting.
Because of that color filter, you lose a little bit of resolution depending on the scene you're looking at and depending on the demosaic algorithm that converts that Bayer pattern into RGB. So a mono sensor completely lacks that color filter, and it's just
Yep.
native monochrome pixels that are sensitive to the whole spectral range. So you get about twice the sensitivity, and depending on the scene,
Nice.
almost up
Yep.
to twice the resolution.
Oh,
Ooh.
wow. That's
It
intense.
depends.
Okay, what? So the quoted resolution of this sensor, the 1280 by what is it?
1280
1400.
by
That
1024,
doubles.
yeah. Well,
That
no,
that
it's
doubles for.
in certain situations, like if you're looking at, for example, a pure blue object, that'll be half on the color sensor.
Oh,
Yeah.
right, of
For-
course,
For
yes.
a typical scene, it's
Yes.
almost 1-to-1. It's not that bad, but for certain edge cases, it can be pretty bad, and that's where you don't have that problem on mono.
Right.
Wait,
so if
why-
you were
wait,
shooting
wait.
an object that was blue, so if you've got a car that's blue and you're filming the crash test of this car, then you'd get half the resolution, roughly,
About that, yeah.
maybe, because it's blue, because you're shooting in.
Is it because you're throwing away
Color.
all the red and green data? Is that what it?
Yes, because like the only
Right.
pixels that would light up would be the ones with the blue filters, and that's only 1/4 of them have that blue filter
Oh, because the
Right.
filters actually exist on the
on the
pixel.
die. Yeah.
Yes.
Oh,
Yes.
okay, that's interesting. So it's like you're like selecting in hardware, and then you're basically like downsampling in the physical world.
That's right. Yeah.
I've got in one of my teardown videos of like an old Sony camcorder or something, I actually look at the sensor under a microscope and you can see the RGB filter strips in there. You can actually see the strips. It's really,
That's
It's
cool.
really cool. So what typical, who would typically use a monochrome version like that?
If you're doing
Are you targeting a certain market
yeah,
for
well,
that? Or?
usually if you want to run the camera at low resolution to get the highest speed, you usually want to get the best resolution possible, so you may use monochrome there. I had one person who requested it to, I think they wanted to film bats, and they wanted to illuminate
Right.
the scene with an IR light, so that would be, in that case, you don't
yes,
need color.
perfect. Yep.
And it's sensitive to outside the visual range. Is
Yep,
is that right?
sensitive up to around 900 nanometers, I think.
Oh wow.
Yeah, the color version actually has to have an IR cut filter to remove everything above about 650. Otherwise, IR gets mapped into colors weirdly and things look wrong.
Right. Got it. So if you're doing nighttime stuff that's IR illuminated, then you choose the black and white.
Definitely,
obviously.
yeah. It's
Yep.
just most
Got
people like color just because they want pretty shots. But there's a
Yeah,
lot
yeah,
of
of
benefit. Once
course,
you actually
yeah.
use the mono camera, it's actually very nice in a lot of situations.
Yep.
So is that why if you
Excellent.
take filters off of certain like webcams, you can get like IR sensitivity too? Like it's just innate to the CMOS.
Yes, yeah. That's a hobby. A lot of people have to take out the color filter, and you get really interesting. Like I think trees light up like a whitish or pinkish color rather than the normal green.
That's cool.
Very cool. All right. See, that was an interesting
That was
tangent.
you're
Well
right. I'm
worth
glad
it.
you
Thank
asked
you
that.
very
That's
much.
that's good.
Yes. All right. Back to our flow. Where were
So
we up to? The
David,
processor.
could you summarize maybe like so what's coming out? I can't really see in my mind how much of this is contained within the FPGA, right? So you said it's 50%.
So everything we've
yeah.
been talking about is in the FPGA so far.
Oh, really? Okay. So
Yes. Including generating that RGB color space
Yeah.
signal.
so you're doing all this stuff in Verilog, is that right?
All in Verilog, yes.
Okay.
Yeah, it's all
Any reason for
relatively-
Verilog? We always ask that.
I like the syntax much more, sort of C-like. I'm familiar with C. VHDL is, I don't like the verboseness of it, but
Yep.
there are certain advantages, and it's more capable in some ways. But I like nice syntax and not duplicating a lot of things like you do in VHDL.
Yeah.
Sure. And all the tools for these are free, are they, for your
The FPGA
development?
The dev tools are free for the ECP5. The one thing that's not free is the RAM controller license.
Oh, okay.
Okay.
Yep.
Other than
How
that,
much does that cost?
that's about $500 a year, I think.
Okay, so
It's not too horrible.
You're right. Yep.
That's for like the IP?
That's the IP
like-
core, yeah.
Okay.
Yep.
Yeah, that's I mean, if you really look at it like that's saving you a lot of time, not having to
Yeah,
write
so
your
that
own,
would
right?
that's like a year's project to do a DDR controller.
Yeah.
So do you get the source for that?
No, they give you this. They give you an encrypted source along with and then some non-encrypted config files and the program that generates all the config files. Yeah, I wish they just give out the source.
You're right. Yep. But then it'll leak and
I don't.
everyone.
But it's so tied into the hardware in that chip
Exactly,
that you
I
couldn't just
know.
copy it.
They're selling hardware. I know. Anyway.
So
yeah,
okay, so
big
then
business.
what is your interface out of this FPGA then? Because
There's a few. There's to the CPU. There's two of these 24-bit RGB streams.
Okay.
What else? There's not much else. There's a GPMC bus, which is basically just a 16-bit parallel bus that you use to access registers in the FPGA, so the CPU can control settings in the FPGA.
Oh, that's nice. So that's like when you're using the click wheel and trying to change stuff?
Yeah, like when you change a frame, just writes a register, oh, I want to display this frame, the FPGA goes and does that and starts spitting out video. And there's a few other minor things. There's some the trigger I/O is connected to the FPGA. The ADC for the analog channels is connected there too, so it can buffer the data right onto acquisition RAM.
I'm having a panic attack thinking about how much FPGA knowledge there is in this
So
thing.
much stuff in this.
Yeah.
This is a massive
It's really
project.
impressive, though. Like, it really
is this one of the most complex Kickstarters you've seen? Like in
yeah,
terms
it's
of
one of the-
hardware and software development?
One of the most complex projects I've seen basically a single person do that I know of.
Same here. Yeah, I thought it was. Yeah, I don't think I've seen anything
it's
harder.
reminiscent of like, I mean, Jerry did a lot of FPGA stuff too, and I mean, it's reminiscent of that. I think, but the scale of the number, I don't know the internals of the Castellar stuff, but like, it seems like it's the FPGA stuff in general when it's doing this fancy image processing stuff. It's nuts.
Yeah, there's so much stuff, so many. It took a long time to develop, but it was a really fun project.
Good.
But yeah, it's so long, so it's like I just want to get this done. I have other projects I want to do,
Right.
but got to get this out.
Oh no, dude, this is the
Did
rest
it-
of your career. I don't know if you know that. I mean, this is
So,
gonna, yeah.
did you have this end goal in mind that you'd produce a product to sell, or
I guess sort of in the back of my mind.
at what point did you go, oh, I think, yeah, I'm going to take this serious now?
I think sort of in probably around 2012 when I had the first sort of alpha prototype on the way to running. I was thinking, yeah, hey, I can actually maybe sell this, and this new Kickstarter thing is out. This would be useful.
Right. Okay. So you've been thinking about it for 4 years.
more
maybe.
years. I'll wait.
Yeah.
That's what you're
Yeah,
thinking.
yeah.
And now we wait.
Now it's finally there.
Were you at all tempted to do the Kickstarter thing and saying, oh, look, I've already got this prototype that I've been working on for a few years, and I'll just go do the 3D renders and everything else, and then I'll get all the money, I'll get $1 million, and then I'll hire a team. Was that ever a...
I was not happy at the state of development. Like I asked myself, would I be confident in selling this? No, I wouldn't.
You're an engineer
That's
and not
right.
an entrepreneur. That's your problem. That's,
Business person would bust through that barrier,
I know.
raise a shitload of money.
Yep.
And the competitor camera, the Edgertronic, came out in 2013. And it was quite similar, but like they did a pretty good job, but they made a few mistakes, like not having an onboard LCD. You had to connect it by Ethernet to a computer, and you need to tether it to a power supply, and it was a lot of effort to use. But apparently they've sold 700 of those at $5,500 each.
Oh, okay.
Wow.
And that's...
Now, there's another competitor that was on Kickstarter, wasn't there?
Yes, FPS1000, which was... I was really surprised. That's the project where I found out how fast Flash is.
Right.
Really?
Yes,
I had
because
no idea.
people talked about that on the forum. They write directly to Flash, and I thought, oh, shit, that's not possible. And then I thought about it for 10 minutes, and I thought, oh, yeah, they could probably do that.
Yeah, then I looked it up, and these Flash
Yeah,
chips, a single chip, you can write 200 megabytes a second sustained to.
Yep.
The only issue is, I looked up the data sheet. It's 60,000 write cycles, so if you leave it recording in a loop for 2 weeks, it will completely use up the Flash's life.
So
Don't they use Flashware leveling?
But the problem is when you use the entire Flash, so there's no
you
point.
use the entire Flash, right?
Yeah.
Yes, of course. Right, so that's their problem. So that's their issue.
Yeah, I mean, it's a really ingenious design. Hats off to, I think it's Graham Rowan for coming up with this. It's way cheaper than you could do it with the architecture I'm using, but it's just, there's some issues with it.
and it's
Right.
been delivered. Is that right?
Yeah, they got £125,000 and it's been delivered, I believe.
I've heard some haven't. I've heard conflicting stories. I'm not sure about that.
Right,
But he did run a
okay.
second Kickstarter just a couple of months ago because he needed more money, apparently.
Oh yeah, I'm looking
Right.
at the updates. Okay.
Yeah, I think that was FPS 1000 HD.
Okay.
Oh, okay.
Rebranding and new
And
product
it's
launch. Yeah.
significantly cheaper than yours. Is that because they went for the FPGA solution, or is it sensor? What's
Lower cost
the case
sensor.
isn't as nice?
a lot of those. That's on the first one, FPS 1000. Those are the case. On this new one that he just released, he's actually using the same sensor I am, and he's selling it for, I think it's $2,200 US. So it's a little bit cheaper than mine.
Okay, a little bit cheaper.
Yeah.
Okay, got it.
But yeah,
I don't see that on. Oh no, because it's in pounds. That's right.
Yeah.
It's 1,300 pounds. Okay,
Yeah.
when you can. No, sorry, 1,900 pounds.
Yeah.
Okay.
The one issue with that is he doesn't have the system on chip with H.264, so it only saves to RAW format, which it's huge files and you have to process it in your computer, and the workflow is difficult.
Gotcha.
Got it. Okay.
Well, it definitely is a nice product, though. I mean, like, this looks nice.
Oh,
too,
definitely, yeah.
Yeah, that's great.
Cool, but it doesn't have the same sort of system capability your one has with the synchronization and the I/O, and you've even got analog inputs. You can superimpose waveforms over the top, which I think is a really cool idea.
No, it doesn't do any of those. It's a low cost. It serves that low cost market.
Yep, got it. So, but you were shooting for like the professional industrial market.
Yeah, I was trying to get into that, but still be at the price point. I felt sort of like the $2,500, $3,000 was the price point where like people buy DSLR cameras that are that expensive.
Yes,
it's not completely
they do.
ridiculous.
Yep, true. Okay, so you went into this with a price point in mind.
Yes. Like the old version, alpha version that used the other sensor, that would have sold for probably $5,000.
Wow.
So that I don't think it would have been anywhere near as successful.
Yep.
I'm very glad.
True.
I made it I was feeling, is this feature creep? But about a year and a half ago, was like this new sensor came out, the Luxima one. I was like, should I change this? It's like a fifth the price of the other one and twice as fast. Yeah, I'll redo the whole thing. I think that decision paid off.
Yeah, no, that was a good decision.
But yeah, that set the project back at least a year and a half.
Wait, you did redo it?
Yeah, I basically threw out the whole thing and redid it.
Oh, wait.
Wow.
But that's not the Luxemon one. You mean the...
No, the one I previously was using was the ON Semiconductor Lupa 1300.
Okay.
Mm-hmm.
Yeah, and that sensor's like $1,500.
Oh.
That's just...
Yikes.
Yeah.
Yeah.
And it's only half as fast as the current one.
Yep. So that's why you went, bugger it, I can't make a viable business out of that.
Edgertronic is too much of a competition in that segment, so I got to change this.
Yep.
And how long did that redesign take?
And it took you a year and a half.
I started it. So I first prototyped the sensor on the old alpha version in mid 2015. I started laying out this new version in beginning of this year. Okay. Got prototypes in June, and then it's just been a sprint until now to get it running.
Yeah. How long did it take you to do the schematic and the PCB layout?
Schematic was generally just a copy of the old version, so that wasn't a huge change. That was like a few weeks. Right. Then PCB layout was about, I'd like to say about 3 weeks or a month.
Yep, that's typical. Yeah, and how many layers?
8 layer.
Oh. 8 layer, because you need to fan out the 600 pin VGA.
Just no way you can do it on any fewer.
No, you can't.
Oh, and so you ripped up all the FPGA stuff too.
I changed the FPGA. I packed 2 boards down to 1. It was a complete redesign, complete relayout. Only the schematic was generally the same.
Yeah. Wow. But the form factor stayed the same too, right?
Pretty much. It got a few millimeters bigger, but definitely worth it to go to 1 board, because when I had 2 boards, about a third of the space was taken up by the board-to-board connectors and the traces connecting to them.
Right, and they're not cheap connectors usually either.
Those are expensive. That's like $40, $20 worth of connectors there.
That's how Samtech makes their money.
Yeah.
And they make their money.
They're very nice connectors.
Yeah. And there were other issues.
And their sampling service is second to none.
Yeah.
So what's the major thing driving the cost in this, or is it just a combination of everything?
I'd say the image sensor is almost a third of the cost. The main board is about another third, and then it's all sorts of random stuff like battery and boards and assembly and LCD and all that stuff. Housing, yeah.
Got it.
Wow.
What sort of contingency do you have price-wise if things go wrong in production? Can you handle all your boards coming back failed? Can you?
Yeah, for the the early bird batch is about 25, and I can handle, like, if those boards completely don't work, I can easily handle building. It's like about $10,000-$12,000 to build a whole nother set. So I can do another design spin if needed, and it's not the end of the world.
Try not to do that, though.
Okay.
That's what I've learned.
I'm not going to
Try
build
not to do that.
100 of something right away without testing it in some way first.
Yeah.
So did you deliberately price the Kickstarter to factor failure in?
I sort of will price the early bird versus non-early bird rewards to have this buffer of a smaller quantity as a buffer. Mm-hmm. And then, obviously the later rewards are a little bit more expensive just because give a bonus to people starting out, getting in early.
Yeah.
You're right. Yep.
Huh.
Interesting. But
okay.
Because this is almost pre-production, well, it is basically production. You said you're going to respin the board a little bit. So is that the only risk at the moment? Although you have a lot of stuff to write in the firmware.
Yes.
You're changing the OS, aren't you?
Yes.
Sorry, not the
not
OS. The OS is Linux. You're changing the development tool chain.
The tool chain, yes.
Yep.
Because of some limitations in TI's, what I say, almost complete dropping of software support for their chips, I have to switch to this from the TI SDK to this Ridge Run one, where they actually have implemented a lot of these features that I need. Like
right, so this is for the TI. This is for the TI processor. Mm-hmm. This is for the DaVinci processor. What does that TI development kit do
it's basically the Linux build, the kernel build for U-boot, and the file system that goes on the card, like that has all the main file system for the Linux system.
Mm-hmm. Does it have video drivers and all that?
Yeah, it has all
the
video drivers, all the drivers for that special input hardware for the H.264 compressor. But it's just basically featured. The Ridge Run one has many more features, some of which I really need to implement some of these interesting record modes.
You mentioned that the TI SDK does not support 2 video streams at once.
Yeah,
and you need that for your run and gun mode where you're recording video into the memory plus you're saving it and processing it at the same time or something.
Yes, so you need one stream to display onto the LCD and one stream to send into the compressor that goes onto the card, so you can continue shooting while saving.
Oh.
And that just can't handle it.
And it just I asked on their support forum, we only support one stream at the moment.
Right.
Interesting.
So this Red Lake, is this like a third-party thing? Or
it's a Ridge Run? Yeah, it's a third-party
Ridge Run
company that they seem to cover almost all of TI's chips, and they seem to have much better documented stuff. They'll provide support, but of course you have to pay for it.
Yeah.
I think it's like $5,000 for the license.
Again, but you're basically buying an employee at that point, right? You're basically
sort of,
buying. Yeah. What is this Linux build then? I mean, is it some flavor of Linux or what is?
I think it's called Arago.
Okay, it's some like shrunk down
that comes
something.
Up. Yeah, it's pretty much shrunk down. TI's customized it with all their drivers.
Okay. Mm-hmm. Oh, that's intense though.
Yeah, it's been interesting.
So is that the risk? Have you actually tried this Ridge Run thing?
Not yet. I've been waiting for the Kickstarter because I don't want to drop $5,000 on it yet.
Right. Is there a backup plan if it all goes tits up?
Then I will just have to develop it myself, and it will just take longer.
Right.
Yeah. Like all the stuff to do it is there. Like Ridge Run has done it. It's just the case of timing.
Yeah.
Could you deliver if that comes to pass? If look, sorry guys, I need another 3 months to work on this. Could you actually deliver the hardware to backers and give them the current firmware and go, look, I'm still working on the firmware,
yes,
or how
definitely.
would that work?
Yeah.
Right.
Because the firmware is stored on an SD card, just like a Raspberry Pi, so updating it is no problem.
Oh, that's great. So just boots direct, huh?
Yep.
Oh, that's really nice.
Got
then.
it.
There's no brick in your SD card.
No.
So there's little risk in actually getting hardware to backers with some sort of working hardware to backers. Right?
Yeah. Like I do have to test a couple of things. You test some audio, the audio stuff. I do test the analog stuff, but pretty like all the main video stuff is working. And even if it didn't have some of those, I think most backers would still be very happy with it.
They'd still be. I'm happy with mine, and mine's got no audio and lots of other
audio,
no run and gun mode. And,
almost no other cameras have these features really, so it's it's a bonus.
Yep, and the waveform on screen, because you've got some ADC inputs on this, which I think is very novel. And you, in your demo, in your Kickstarter video, you demo, you would have like waveforms. You could feed in signals, like test signals coming from sensors. What application do you envisage that being useful for? Is there a particular case, or did you just think, hey, I don't know?
Oh, a few things.
I have no idea, but it might be good.
You could visualize audio and signal and see how a speaker moves. You could do, like I'd shown in the demo, like an electric motor, seeing the 60 hertz waveform and how the motor accelerates and how sparks occur. You could visualize pots.
Was that a real demo you did, or was that like
that's
Photoshoppy
mocked up.
kind of?
Yeah, I don't have actually working hardware, but it'll be something like that, or it will save to like a binary data file or CSV or whatever.
Oh, so it's like this is a logging function. Is that the idea?
It's basically a data logger. Yeah.
Okay. Oh,
and it's superimposed on the screen in real time as you're shooting, right?
Yeah, or as you play back.
Or as you play back. Sorry, because it'll be too high frequency to see it. Yep.
Wow.
Cool.
So you basically are starting like a science company. You know, like it's like this is going to be like scientific.
People were saying like they wanted the camera just not even for high speed, just to develop FPGA image processing.
Yeah. Yeah, like a dev kit.
Okay, as a platform. Maybe you could just sell the board as a dev board.
Possibly, yeah.
Wow.
Get your quantities up.
Depends what people want. Some people were asking me, can I buy a sensor? Can I buy a monochrome just sensor board and a color camera so I could swap the two?
Yeah.
And I was like, if you're confident, I'll sell you one.
You know what I would say is that I don't know if they're listening, but maybe some of their employees are. But if I was Lattice, I'd be like, hey, David. I would love to, pay you to rebrand this as one of our dev boards. Or if I was TI, I would listen to this and be like, I'd love to make this our dev board. And then, exactly that, right?
I'm actually wondering if Luxema may want to sell. But I think this camera is, if I recall, it might be cheaper than their dev system for their sensor.
Yeah.
Actually, no, I think it's about $2,000.
Wow.
No, their dev system was about a couple of grand or something. I don't remember exactly.
Right.
Wow.
Or they could just acquire you outright. They can just, if you do you want to buy a Canadian? We'll sell you a Canadian. The Amp Hour is selling a Canadian. Luxema, TI, Lattice. Give us a call. We'll give you a great price. Canadian dollars.
One thing I would not do, I would not sell out just to have it suppressed.
Right. Of course.
Right. Yeah. Yes.
So
where do you see?
Yeah.
Where do you
10 years
see
of your life down the drain? You don't want to just make it.
Where do you see the company going? Because this is your full-time job now, basically. Do you have plans for taking on people?
Yeah, definitely looking for a software engineer, someone who knows the embedded Linux side of things. I'm not as familiar. I could definitely use help there.
Well, we happen to have an audience listening right now, and we have a great track record.
We will sell you some nerds, David.
Yeah.
We've got nerds.
Let's just hope the Kickstarter does really well and I can afford to pay people.
Yeah, right. You might not even...
So are you like interviewing people now? If somebody's actually someone's.
Do we have an email address we could send resumes to? That's what Dave's really getting.
Yes.
I will set one up. Yep.
Okay.
Cool.
But one person who backed the cameras is done a lot of Linux stuff, and he's interested in doing helping with some software. Like he's currently working on fixing doing a boot splash screen and fixing some of the boot up time issues.
Nice. Yeah, right. Community stuff. I mean, that's going to be great too, right?
Yeah.
I mean, it seems like that would be a good crossover.
Yes.
Yep.
And I'm sure there's a lot of software people out there that have a lot of excess cash sitting around that want to film water balloons popping and stuff too, just for funsies.
Have you looked at the potential market worth of this this camera at this price point? What sort of volumes do you think you could sell if you were successful?
Just judging by how Edgertronic sold their camera, 700 of them at twice the price, I can imagine that it's much more than 700s. It could be into the thousands.
Over how many years did they do that?
That was 3 years.
Okay, right. So are they the go-to one at the moment for that sort of price
for
point?
like real professional low cost high speed?
That still seems low to me. I mean, how many universities and research groups and other, companies that want to do this sort of thing. Like, I can imagine just, one car company want to do crash testing and stuff like that. They'd order 50 cameras or something, It's like pittance for them.
I think it's just they're being held back by the lack of slightly poor usability requiring the computer, etc.
Okay, so it's a system problem.
It's probably, I mean, it's a great product.
Right.
They did a really good job. It didn't quite hit the market perfectly, but it still did very well.
Got it.
Can I ask a pessimistic question? Are you worried about people ripping off your design? I mean, we usually
Not
talk about openness and
particularly.
stuff.
It's pretty much secured by the FPGA bitstream security.
Oh, it is? Okay. So,
So
that is a way to
as long
do
as I
it.
keep that secure, the design's like the majority of the effort was making the FPGA firmware.
Okay. Well, that's...
I suspect at this sort of technical level, like no one's going to rip it off.
Yeah, it's not like a
If you know
low-cost
how to
product,
do
right?
this, you're
Yeah,
going
it's
to make
not a
your own.
low-cost product.
That's a good
Yes.
point, yeah.
Yeah.
Okay.
It's not like you hear
exactly.
these stories of Kickstarters happening, and then the Chinese are selling it before the Kickstarter's even done. But those are like
That's
very
because
simple.
it's a $50 product.
It's like a mechanical
it's a mold.
device mold.
Yeah.
Yeah.
Yeah, that's it. It's
But-
copied. Bam. No, this
This is very different. Yeah.
yeah, entirely different. So no, I wouldn't be concerned
No.
with that. Not at all.
We had some questions on Reddit, which I will kick myself if we don't get to.
Sure.
Oh, right. Yeah, I forgot about that.
I think a lot of them we answered. Mike Harrison asked about the sensor cost. Wegmat asked about the journey and logistics. I think we got all that stuff. The one at the top, though, Genlock, is there any support to Genlock 2 cameras? So I'm guessing there's a lot of industry type of interplay type stuff. Is that what this is? I don't quite understand what this means.
Genlock is being able to synchronize the camera to take frames synchronized to another source. So yeah, it will support that. And then basically you can either have it like a rising edge trigger an image to be captured. You can have the shutter be directly controlled by the level on the trigger, like just expose while high. Yeah, those are the basic two modes of doing Genlock.
Okay. And then what about the, so then this is Maurice who's asking this about this, but then also the, do you have recommended lighting rigs? I mean, so we saw Mike doing that 600 watt incandescent. I mean, do you have other high power type stuff?
Well, I'm not really selling it, but I built a 5 kilowatt LED lighting rig that I have a video on.
Yeah, that's
on YouTube.
cool. If you haven't seen it, go see it.
So why aren't you selling it?
It's a whole nother product, and it's not. It requires water cooling and expensive power supplies.
Yeah, no, that's messy. That's
Yeah.
messy. Don't go there.
You can buy.
Yeah.
I would suggest people can just buy there's cheap LED film lights. They're super plentiful.
That's actually what I got in the mail right before the show.
Yeah.
I don't know what the output is, but
no, that is a market you don't want to get.
Yeah.
You're just going to get beat in that
I'll
market.
I'll open source my like water block design if people want it, and maybe if enough people want it, I'll sell those. But I don't want to sell the complete thing. Like
Got
getting
it.
UL approval and the power supply is like $20,000. It's just not worth it.
Got it.
Now, Nick 282000 wants to know what the real data rate from the sensor is. The data sheet says 1.5 gigabits.
Yeah.
Bit
versus bit was what
gigapixels
we
per
were-
second.
Yeah.
Yes.
The real data rate is just a second. Let me calculate that.
Are you using Windows calculator or a real calculator?
I'm using Windows XP calculator, not the Windows 7 one.
In scientific mode or in just normal mode?
In scientific, because in the Windows XP calculator, they made the key combination that does square now does square root.
Seriously?
Yep.
Wait, what was it before? It was slash?
Get a real calculator. Get like.
And my escape.
Your-
Just a minute.
Your entire reputation is now down the toilet, David, because you're using a Windows calculator.
We're gonna get remixed just David using Windows calculator over some techno music. You know? Calculator. That'll be after the
You have
after
to
the
insert
outro. Yeah.
you have to insert MC Frontalot's song about calculators.
Oh, okay.
Why was that vacation germane to the math? Because of good data policy in the office and the vast.
I didn't know he had. That's your favorite
MC
nerdcore guy. Right?
I was going to actually feature in that video. He actually approached me and said, "Hey, I'd like to use this voice clip from one of your videos," and they actually remix it into the song.
Oh.
And it didn't make the final
Your
cut.
chance of
I
fame.
don't
Sorry,
believe.
Dave.
Yeah, it didn't make the final cut. Or it might be hidden in there somewhere, but I just didn't notice it. So,
Okay, the final
anyway.
data rate is average 3.1 gigabytes per second.
Gigabytes.
Gigabytes.
Yeah.
Yes.
Okay.
So multiply by 8 for bits.
Yes, so 24.8 gigabits per second.
Right.
And that's coming out of the...
That's coming out of 8 lines?
16.
Sorry, 16 serial lines.
Yeah.
Right.
Yeah.
Jeez, that's a lot of data.
Yeah, that's pushing...
So 28 meg divided by 16. So we're still talking about 1.2...
1.08, yeah. It's really...
just over a gig per SerDes.
Yeah.
So each SerDes has to handle 1 gig
Yeah.
Right.
data rate.
The limitation
would the hardware...
Oh, go ahead.
One handle would the hardware SerDes handle that, or
yes, easily, but like 3 times that. It's just the number quantity.
Yeah,
The
they have like
limitation-
standard
Service,
numbers for those for some reason. It's like 5.6 gigabit, right?
It's weird numbers. Yeah, I don't know where those came from.
23,
Yeah.
24, or something like that.
Yeah, but the limitation is pretty much RAM. Like I'm pushing the limit. The theoretical bandwidth on the RAM is about 4.8 gigabytes per second. So we're using more than 50%, more than like 60% of that.
Oh, wow.
what if it was just what if you got through halfway through this design and you went, oh, it's just a smidgen over the DDR3 data rate. I can't do the maximum resolution. What would you have done? Would you have gone to DDR4 or?
I'd probably reduce the speed or increase the RAM clock slightly. Either reduce the image sensor speed
you'd
or
overclock. You'd go, oh yeah, I can overclock this baby. Right.
Wow. Wait, so how close to the margin are you right now? I mean, or how much margin do you have, rather?
There is, so that is 3.1.
I love we're doing
65%.
calculations live on the show.
65% of the theoretical bandwidth.
Okay. Well,
Oh, that's
I've never seen an image artifact due to like RAM over or underflow, so it's solid.
Right.
okay. That's great.
Nice.
And then, okay, so then so this is all self-contained at this point, right? So then you can also push to like a recording medium like a SD card or some kind of physical medium then?
Once you have your recording saved in RAM, you can save it to SD card, to USB, to eSATA drives. You could save it over a network to network share.
Okay.
However you want to get rid of it, yeah.
And that's just the standard output from Linux drivers driving to these standard ports. Is that the idea?
Yes, yeah. That's one nice thing about Linux is all this stuff that would be a massive difficulty to do on your own is all just taken care of.
Right. If you were doing just like an embedded platform from scratch or something, like that would be. That's why the old scopes all struggled even putting stuff on the USB drives, right?
Yes, they finally got that working like mid 2000s. Like that took a while.
Yeah. That is, that's true.
What was the hardest part of this whole thing? What was the one that really kicked your ass?
Probably the most worried I was getting the RAM working on the ECP5. I was a few weeks away from my deadline of, if this doesn't work, I'm going back to ECP3.
Oh,
but I was able to get it working.
Sweet.
And you said you have to pay...
Did it just magically work one day, or did it just partially work and you were able to figure it out?
I was able to partially work. I was able to hack some of the generation scripts, and it was able to make it work.
Sweet.
Wait, and you're paying $500 a year for that DDR controller that doesn't really even work?
I should ask for a refund.
You totally should.
Totally. Yeah, that's or sell
Just
it.
Work it into the deal when they ask you to become a dev board.
Totally.
Yeah.
No, they should get on that.
How did you set the price on this whole thing? I know that kind of switches topics.
I think we answered that.
Did we?
I sort of had a price target of this like 2,500, 3,000. Sort of just had to make the hardware fit within that.
Okay.
Yeah, you use a lot of commodity parts, put a lot of effort into pulling cost out of the BOM, removing expensive parts, using lower cost ones.
Yeah. Okay. Sorry, Dave, I cut you off.
How much time did you spend on the software versus the hardware? Because this is just as big as software project. I mean, I can't imagine writing the software for this.
Probably 4 or 5 times as much time on software as hardware.
Wow.
There you go. Yep.
Easily,
For all you newbies out there who think something like this is, I mean, this is one of the highest end hardware projects I've seen on a Kickstarter, and you're saying it took 4 or 5 times longer to develop the software. I mean,
like just to get an example, this is probably I was learning. It was a very steep learning curve for learning the embedded Linux stuff, but it took me about a month and a half to figure out how to switch the UART from UART 0 to UART 4. Because there's like 10 different places in the kernel source tree that I had to go find and change these register values. It was horrible. Don't become a current Linux kernel developer, no.
Oh, this is...
Mama, don't let your boy grow up to be a kernel developer, huh? Wow, that's crazy.
That's insane.
I'm sure it would have been it would be faster for me to do it now. It was just that learning curve, learning where this is. I did so much search everything in the whole kernel directory for whatever term, and finally, so I sort of know where things are now. It's a little bit easier.
Right. Wow. 10 years of development to get to this final
I can't believe it's been that long.
I think that you don't really think this is going to end after the delivery of stuff, do you?
No, I want to do more cameras. There's lots of more nice sensors out there.
Okay, so you're not like, I'm going to go build Wi-Fi widgets. You're like, I just want to build different stuff.
All the things I want to build are weird, esoteric things that have not been done before.
Okay.
Or fix some problem in a much better way.
Any hints?
Does that...
Good, yep.
Any hints?
Any hints?
Yes.
I wanted to work on a raster scanning laser projector, and I have an idea how to do that and get full 1080p resolution.
But is this taking focus away from the company you're trying to build?
Yes,
here?
that's why I'm not doing them right now.
Yeah. Right, and it's not like, oh, I've delivered all my things, now I'll go work on my fun little
project. If I want to keep the company
You've got
going, I got to keep updating, making new products. It's just a never-ending cycle. Otherwise, someone else is going to come in.
Do you need a new product though, or I think the systems integration here is more important. Providing solutions for people who want to have multiple cameras all synchronized and tied together and big rigs.
Yes, definitely. I think
stuff like that. I can see that being where you can add value. Like, not just selling a one-off camera and that's it.
Yeah, I think that's definitely something where other companies haven't really focused too much on.
So are you going to do that? Because I can see that being your differentiator.
Yes, I think
provide system solutions.
And once you've got those systems, the whole CPU side is sort of disconnected from the image sensor side, so you can just swap in different sensors, different FPGAs, make a faster camera, and all that other stuff is all done.
Got it.
That's sort of where I want to take this.
You list at the bottom of your page, this thing is going through FCC Part 15, but it's not a big deal.
I don't think so. That's probably, I shouldn't say that because I'll have bad luck. But
because you're doing the worst possible thing for a product here. Massively high-speed parallel digital stuff.
Yeah, well, as soon as possible, I'm going to book a time in the local test lab. Hopefully I can try to get some video of that. They're often pretty picky about NDAs with other people's products sitting around, but I'll see what I can do.
Okay.
Getting some video of actually debugging this.
Is this a showstopper for delivering product to people? Can you still deliver even if you fail?
Yeah, that's a good question. Like if it
because they're like prototypey, like they're not
deliver a certain number. I forget what it was.
Because these would not be classified as consumer product.
No.
They'd be classified as a perk.
Yeah.
I mean, it's not even a product, right? People aren't buying the product. They donated you the money.
Yes.
Right? And
so for Kickstarter,
you're giving them a free gift.
That's probably okay, but not obviously selling them directly.
Oh, of course. Yeah, that's different.
Yeah. But that's why I sort of built in room for at least one PCB respin.
Yeah, that's good.
Right.
So I can
as in financial buffer.
Financial room and just time,
Time. Yep. When are you scheduled to deliver these?
Early birds in March next year, and the non-early bird normal ones in May.
March of 2017?
Reasonable.
Yeah.
Good Lord, man.
Dude, it's the 1st of December today.
Yeah.
I know, that's what I'm saying. That's why I say it's really close.
Yep.
Like, yeah.
I think it's reasonable, but considering the one I've got in my hand right now is practically the finished product.
I think a lot of Kickstarters you see 1 year timelines these days.
Oh yeah.
So
like I'm working just before this, I was working on those revisions on the final PCB, and I should have that sent out to manufacturing within the next couple of weeks. So get ahead of schedule.
Yeah. How much money do you think you've spent on this of your own money?
Probably
because it's all your own money up till now.
$35,000 or so.
Okay, so you are keeping track?
That's just estimate.
It's an estimate. Okay.
Yeah, it's over 4 years. It's not that bad. Like it's not like paying a person.
Of course, yeah.
Yeah, but it's still still a decent amount of money.
Yeah.
Yep. That's more than most people put into a Kickstarter. Let me tell you. This is how Kickstarters should be. You pony up your own I know that's not the original intention. The original intention was to use the Kickstarter to get money to then, because you didn't have any money, to produce the product, but it's just being abused.
But the difference would be like if you were supporting an artist before, it'd be like the difference would be paying someone to go to start painting or paying someone to go figure out how to paint, right?
Right.
Yeah, that's a big difference.
Yeah.
Right.
But yeah, I like going into things more confident rather than less confident.
Yep. Because you're an engineer and not an entrepreneur, in quote marks. If you're an entrepreneur, you wouldn't care about this sort of thing. I'll just farm it out to somebody, you know, and someone in China will magically, at the Oompa Loompa factory, will make it for me. Yeah.
Well, that does beg the question though. So are there any downsides to you not being the? I mean, I don't know how much business experience you have. I mean, are you worried about any of that side of things, of the logistics or the, you know, like the moving forward type stuff, right? I assume this is going to work.
But it's only 100 cameras. Like it's only
that's
if the
this.
Kickstarter super explodes into 1,000, then I'm starting to have to worry about getting a
You're in
commercial
trouble.
space.
Yep.
But if it's just
No.
I built 12 of them. Building 100 is not that much more difficult.
Right.
I mean,
at what number do you think that you would have to change the way you do things?
Probably in the few hundred, I would say. That's when it starts becoming like difficult to find space to store things. Like we're talking about pallets of parts.
So at the moment, you still plan to do like all the assembly yourself and stuff. I mean, obviously, you're going to get the PCB made in China and assembled in China and all that sort of stuff. But you plan on doing most of it like
but the final assembly
testing yourself.
Final assembly is basically just 15 minutes, so it's not too bad. And then some testing, some automated test sequences afterwards.
Okay, yeah, true.
Yeah, you front loaded all that, and you're redesigning into a single board, I'm sure too, right?
Yeah.
What sort of test automation do you have for your PCB? Is it like just final output, like feed and hook it up, put it in the box, and hook a lens on, and if you get video out, it's a win?
For the prototypes, it was pretty much that, plus I checked a bunch of voltage rails, basically just manually doing what an automated test jig would do. But yeah, for the production one, I'm definitely going to come up with an automated test jig that will test all the voltages, make sure the CPU is running.
Right, so you've built test points into your PCB and everything for that you put it on a test bed. And...
Yeah, like I made sure to put voltage monitoring, voltage points. I actually labeled them so people know what the voltages should be.
Right. Excellent.
And then it'll run through an automated calibration where it takes a bunch of sample images, checks the imager is all working.
Oh, okay.
Calibrates.
Is that built into the firmware or you put special?
That's built into the firmware,
Okay, right. Nice.
Do you expect people are going to want to like access this thing or like upgrade it themselves or hack it, or I mean,
people ask,
too low?
Can I upgrade the RAM? I think people might try to do that.
Okay.
Yeah, they could definitely do that. I'm not doing anything deliberately to make it hard.
Okay.
Right. Is there a limitation why you're not just whacking more RAM in it? I mean, because it only records for 4-point-something seconds at the moment.
Right now, there's two different sizes of sticks available. There's 8 gig and 16 gig in sodium size, and right now the RAM controller only supports one stick. I think I have a path to get it to support 2, and I know this in signal integrity wise, it's fine. Just the controller doesn't support it. I think I can make it work with 2 sticks.
Okay. Got it. So you could potentially double.
You could potentially go to 32 gigs, yeah.
And that'll give you what? How many seconds?
16 seconds record time.
16 seconds record time. Yep.
At any of the speeds?
At any res. Yep.
Yeah.
Oh, sorry, no, it changes with doesn't it?
The record time is about the same at any resolution, just because the pixel rate remains the same.
Yeah.
Oh, right. Okay. Yes, of course.
And that makes me think my calculation earlier was wrong. Yeah, it's about 2.1 gigabytes per second. I multiplied by 12 over 8.
Okay. Oops.
I wonder if people have been screaming at their podcast player for the past 10 minutes.
So having met your goal in 24 hours or like 10 hours or
5
something,
hours. I couldn't get to sleep that night. I was
I was watching your tweets or something, or your updates. Yeah, that was hilarious. It's actually fun when you go to sleep and you wake up with some big number. It's actually quite nice. Yeah. I've done that, and it's like holy shit, what happened overnight? But I guess you couldn't help yourself.
Nope.
You had to watch.
Yeah, my friend was up. We were talking. We just couldn't stop. Oh, no, another pledge. Just watch it. It's more boring than watching paint dry, but people still do it.
Yeah. refresh.
Paint doesn't have as much implications, though.
No.
Yeah.
So now that you've met the goal, have you immediately started? No, because you've got a board spin, right? So when have you started?
Yeah, doing the work in the board
When do
spin.
you-
Probably gonna get that out in a couple of weeks. I started ordering parts.
Are you ordering any parts? Have you started ordering parts
I'm
now in
working on ordering
anticipation of getting the money?
some lenses. Yeah, I found a good
Right,
company
okay.
that has a bunch of these lenses I need, so I'm getting those ordered in.
Nice. So you're ponying up your own money again. How very un-entrepreneurial. Because you're guaranteed to get this money coming through.
Yes.
So you know that, right? So
Yeah.
So you can safely go spend your own money knowing it.
Just
It'll
gonna
come
come in.
through.
Yeah.
Minus 8%, of course.
Yeah.
About 8? I think it's about 8.
I think it's 5% Kickstarter plus 3 to 5% payment processor.
Yeah.
Yep. So how high do you think it can go? Do you think you've exhausted?
I still have a bunch of promo going. A bunch of YouTube channels haven't released their videos yet, so
Oh, okay.
I'm
Yep.
hoping to keep the current momentum up, which would put it. It's about
Mm-hmm.
30 grand a day, so it would put it just about 1 million. That's probably a bit optimistic.
Oh, okay. Oh, yes. I haven't put it on the Kick tracker or whatever. There's a tracker
Oh, yeah,
website
yeah.
that shows current growth and it projects out. Have you found that you're getting consistent?
So far,
ones per day, consistent
surprisingly, I think it's
backers?
varied from 27,000 to 32,000 a day over the last five
That's
days.
pretty close.
Yeah.
Wow. Okay. Oh, but it's only been 5
Only
days.
5
I
days.
guess.
We'll
So
see what
people-
happens.
People are still watching videos, and so who has released videos? Myself, Ben.
Yeah, you, Ben, Cody's Lab,
Yep.
Tauflater Mouse. Those have all released. Hydraulic Press Channel is released.
Oh, have they?
Yep.
I didn't see that.
Yep, they released a couple days ago, I think.
Okay, cool.
Still
So
waiting.
was this your plan from day one? I'm a blogger myself. I know how important this shit is. I know how important their
Yes.
audience is. I am going to target.
Yeah, like
Yeah?
the other ones just targeted the big magazines like TechCrunch
Right.
and Tested.
Yeah,
and I'm going to go a different way, and it seems to
Yeah.
have paid
Yep.
off really well.
Yeah.
Yes.
Well, because eventually
Nice.
the TechCrunches of the world will pick it up anyways, right? Because it'll
Yeah.
be like,
Yeah,
I keep
exactly.
seeing this thing everywhere,
Yeah.
and it's awesome footage, right? Like I
Like
said, I've only
Tauflater-
seen Ben's, but like that
Yeah.
that bullet time stuff was crazy. Like that was so
Yeah,
nuts.
Tauflater Mouse
Yeah, that was very cool.
released his video when he first got the camera almost a month ago, and then it immediately got picked up on all those big news websites right
Yeah,
away.
I saw that. Yeah, but that was a shame because the Kickstarter wasn't ready
Yeah.
yet. So you probably missed a lot
Missed
of
a bit, yeah.
opportunity there. Yeah.
But it seems
Bummer.
they've most of those have reposted it now that it's running, so it seems to be okay.
Oh, okay.
Yeah.
Nice. Yep. Did anyone refuse your offer?
I did.
No, actually, no. I got a few people took a long time getting back to me. Then I offered it to other people, and then those early people got back and say, "Oh yeah, I do want one."
Right.
And then I ended up. I only have 2 cameras plus the bench dev system left here, and there's one sort of roaming
Right.
around in Europe right now to a few people.
Nice.
Right.
That's great.
Oh,
So okay, so what about if our listening audience? I mean, like this is it's definitely a very affordable, like probably the most affordable option out there if you want to do this kind of stuff. But if someone was thinking, I think this might be me. What do you imagine that an amp hour electronics person would use it for specifically? Anything electronics wise, or is it more nature?
I think it's
outdoorsy?
more nature stuff. Like you'll get cool electronics, like components blowing up. You might be
Yeah,
able to
but
do some
that's-
things like the electronics applications might be something like a high current power distribution test where you want to see if your wires are going to fling apart due to the magnetic field or something like that.
Okay. Or what's his name? Who's the guy
Photonic
that?
induction.
Yeah,
photonic induction. Right.
Is he
Yeah.
gonna
Yeah.
is he gonna do one like something blowing up real fast? Man, that pumpkin video he did was nuts.
Yeah.
So did you approach photonic induction?
No, I didn't actually.
Dave, you should send yours, man.
Interesting.
Yeah, I sort of had to make a
Oh,
choice
good.
of who I thought was going to be the best, and those are the ones that I
You
adjusted
chose
into.
Dave.
thought of me.
Good lord.
Yeah, I have to. You have to be on Dave's channel.
I've got a lousy 400,000 subscribers. I'm no hydraulic.
I
press
just
channel.
mean that thing's gonna sit on a shelf now until you come on next time and Dave's like, oh shit, I was supposed to be using this thing, So I'm just saying,
I think your channel, maybe it was just because it was the first, but yours got the most backers of any of the promo that has been done so far.
Nice. There you go.
So definitely worth it.
don't stroke.
I have
We don't
influence.
need this on this show. We don't.
Yes,
we don't,
we
we
do.
don't need
We
to
need
stroke
some
his ego.
backpack.
Okay.
Yeah.
We don't. No. Don't. Please don't.
Excellent. Oh, that's good to hear.
Get a slow motion video of Dave
can
looking
track?
smug.
How can you track that? Can you?
Just based on time, when the video was released and when pledges came
released.
in. But
Because I put a link. Can you see where links come from? I actually forget.
Yes.
See where your traffic comes from?
But the problem was most of the links were from YouTube, and YouTube is just one thing. It just says YouTube.
Oh, one thing. Oh,
Yeah.
okay, right.
Yep.
Fail.
I should have. That's where I failed. I should have made different. You can do special referrer links. I should have done that for each
Yes.
channel.
Yes,
I didn't do that.
Then,
That was a
then
mistake.
you know. Yep. Oops.
Next time.
Do that on your next $1 million Kickstarter. Okay.
Yep. Where are you hoping? Do you have a secret? And like, are you looking to crack the 7 digits? I mean,
I would like to. It's a little bit scary doing that all at once.
Yep.
And in some ways, I
Yeah,
would like to do it later because then I don't have to pay Kickstarter's cut.
Oh yeah.
Yes.
Yeah. Sell more cameras
Right.
later. Yep.
Yeah.
Yep.
And you are going to keep selling these though, right? You're
Oh,
gonna...
definitely, yes. I'm going to set
okay.
up a store, pre-order on my website, and then just sell it directly afterwards.
Well, this has been a solid hour and a half, 2 hours.
2 hours.
Oh, wow. In 2
Hour and
hours.
53 minutes.
What are we missing? I mean, there must be something that we're missing.
Oh, I have lots of stories. Well, I have to come back some other time and tell some of these stories of development.
Yeah.
Yeah.
You're welcome back anytime.
Yeah, it's probably, we need
Yeah.
probably another half an hour of stories, right?
Yeah, we don't want to step
Yep.
on Vincent's toes and, go over the 3 hour mark or anything.
Yep. So, all right. Well, let's end it. It's been 2 hours.
So, okay, so
my goodness.
where can people find you?
Yep, they can find me on my website, krontech.ca. They can find me on YouTube as Tesla500, also as Will It Mo. And of course, I'm on the requisite Twitter and Facebook and everything.
Yep.
Gotcha.
And I asked you this before we started recording. Why is it Kronos with a C and not Kronos with a K?
That was
camera
because
itself.
my significant other suggested the name, and then I didn't pay attention to whether it was K or C, and I just, I'll just whack that on the silk screen. I'll send the board out to production. And then, wait, that's supposed to be K. I've already got that. I got the promotional. I've lasered it on the case. I can't change it now.
Oh, no.
And now we're sort of stuck with that.
Yeah.
Also, the other reason was, if you go Google Kronos, they're going to do it with a C because that's the normal way of doing it. Then you don't have to say, oh, Google Kronos with a K. Oh, was it KR? Is it KHR? I think it makes it a bit easier.
Right.
Right.
But it is by Krontech with a K.
Yeah.
Right.
At least I got
Krontech.
It
that
is by
right.
Krontech
Yeah.
with a K. Yes.
Makes sense.
Awesome.
And then one last thing, we will have an email address that you'll set up if people want to send you a resume specifically, right?
Yes.
Awesome.
That should
So
be...
that's for a software Linuxy penguin geek.
Yes. That'll be...
Right.
I'll make that jobs@krontech.ca.
Okay. And we will link
Cool.
that too.
There it is.
Cool. Well, David, you're a monster, man. I don't know how the hell you did this. Like, monster in a good way. Like, this is this is so impressive.
I was just blown away at
Yeah.
the end there when you said that you have a significant other. Like,
That's
because
true.
the time to do this
Yes.
is like,
It's
you
a
know,
bit stressful trying to manage everything, but it's not too bad.
Yeah. Man,
Yep.
that's crazy.
and you would not have been able to do this if you weren't full time at it now. Really,
No,
would you?
I would have
mean,
been delayed
it'd be-
very at least into the new year.
And
would have
then
been
it probably would have
just been ripping my hair out the whole time.
Yep. Terrible. All right. Well, I hope you cracked the 7
Me too.
digits.
Yeah.
There, it's worthy because this is one of the this is a genuine Kickstarter, not a bullshit entrepreneurial marketing piece of rubbish.
Awesome. Well,
That's great.
Looking forward to seeing more of this stuff and seeing lots of... Man, I love those videos too. I love seeing this
Definitely,
stuff.
yeah.
So
Yeah.
I want to
High-speed
get some
cool.
more. I wish I had more cameras. I would keep shooting more videos. I just set them
You
all
gave
out
them
and give them all
away.
away.
you should set up like if you can ask the people that already have them too to like set up like a tag on YouTube or something. That would be great so like people
Yes.
can just see that stuff.
They wanted
So-
like a support
Right.
forum or a wiki or something. I'll have to set that up as well.
Yeah. Okay. That's good. Well, thanks again, man.
Sweet.
We'll talk to you
Thanks,
soon.
David.
Yep. Thanks for having me.
Catch you next time.
See you later.
So if you could tell us what you had for breakfast this morning, that'd be a good test.
I had mini wheats.
What are mini wheats?
They're these shredded wheat things. Do you have them in Australia? Maybe they're called something else.
Probably, yeah.
Yeah. They're basically just like shredded wheat compacted into these little, I don't know, pellets.
Oh, yes, I've seen that, right.
Probably not a very appetizing way of describing it, but it's correct.
And now I will insert a clip about shredded wheat.
I should record a video of shredded wheat dropping into a bowl and you can just put it at the end. I have to do this now.
And you could do like another one of like it breaking apart, like slowly breaking apart.
Oh, hydraulic press versus shredded wheat.